Welcome to Audio Sleep Stories for Adults. In the quiet space between the rush of life, where deep ideas wrap themselves in the gentle fabric of storytelling, you are invited to listen and let your mind drift softly into peaceful sleep. Today, we embark together on a journey through the world of teleportation, a voyage into the extraordinary hidden beneath the surface of the familiar. Have you ever wondered what is truly happening all around us that we have yet to see? Imagine standing in a sparkling laboratory where scientists manipulate particles smaller than atoms, particles that behave not like tiny billiard balls, but like waves of possibility. Here, quantum teleportation is no longer a dream. It is a real phenomenon where the quantum state of one particle is instantaneously transferred to another, across distances, without any physical passage in between. This breakthrough hinges on a remarkable property called quantum entanglement, a mysterious connection that binds particles so tightly that the state of one instantly influences the state of its partner, no matter how far apart they are. It defies our classical intuition of space and time, suggesting that information itself might leap across space in ways we are just beginning to understand. Close your eyes now and picture this: a photon trapped in a web of entanglement, its identity seamlessly shifted from here to there, like a whisper traveling through the fabric of the universe. No physical body moves, yet the essence, the very information that defines it, jumps instantaneously. In labs around the world, experiments have teleported quantum states over kilometers, laying the groundwork for quantum communication, unbreakable encryption, and maybe one day, machines that can send matter itself in an instant. As you breathe slowly, imagine the possibilities stretching before you, beyond the known, beyond the visible horizon, where the boundaries of space dissolve into endless connection. Rest now, and let the unfolding mystery of teleportation carry your thoughts gently into the night. Imagine standing on the edge of a vast desert under a sky bursting with stars. You close your eyes, feeling the grains of sand beneath your feet, and in an instant, without walking, running, or flying, you find yourself at the peak of a snowy mountain hundreds of miles away. No vehicle, no journey, just a sudden, seamless leap through space. What would that mean? To vanish from one place and appear in another, instantly, effortlessly, as if the universe folded space itself like a page in a book. This is the tantalizing allure of teleportation, a concept that straddles the boundary between the fantastical and the scientific, between myth and possibility. Centuries ago, storytelling cultures wove tales of instantaneous travel across vast distances, from the flying carpets in Arabian Nights to the portals scattered through mythic landscapes. These narratives tapped into a deep human yearning, the desire to transcend barriers, to overcome distance, and to bend space and time to our will. But what if these stories were not just flights of fancy? What if, lurking beneath the surface of quantum mechanics and the fabric of spacetime, there lies a way to make teleportation a reality? The nature of teleportation, when peeled back layer by layer, reveals a complex mosaic of physics, philosophy, and biology. It is not simply the sudden disappearance and reappearance of a person or object. Instead, it is a question that touches on the foundations of reality itself. What does it mean to be somewhere? What constitutes the essence of you, your body, your consciousness, your identity? If teleportation involves disassembling matter in one location and recreating it elsewhere, is the original you destroyed, and is the one who appears at the destination truly you? These questions have fascinated scientists and philosophers alike, leading to profound debates about existence and continuity. From a physical standpoint, the very idea of teleportation challenges our understanding of space, matter, and information. Classical physics painted the universe as a vast stage where objects moved through space, but never vanished and reappeared instantaneously. However, with the advent of quantum mechanics in the early 20th century, the universe revealed a more mysterious character. Particles could exist in superpositions, in multiple states at once, and phenomena like quantum entanglement hinted at connections between particles separated by vast distances, seemingly instantaneously. Teleportation, in its truest scientific sense, is rooted in quantum teleportation, a process first demonstrated experimentally in the 1990s. Unlike the teleportation of science fiction, which moves matter from one place to another, quantum teleportation involves the transfer of information about the quantum state of a particle. This was famously showcased in a 1997 experiment by Anton Zeilinger and colleagues, who teleported the quantum state of a photon across a laboratory. The quantum state is the essence of a quantum particle's properties, its position, momentum, spin. But crucially, the particle itself never physically traveled. Instead, its state was reconstructed in a distant particle, thanks to entanglement and classical communication. This breakthrough was profound, not just for its technical achievement, but for what it revealed about the nature of information in our universe. The famous paper published in Nature, Baumeister et al., 1997, demonstrated that quantum teleportation could transmit the state of one particle to another without violating the no-cloning theorem, the principle that forbids making perfect copies of unknown quantum states. This is a sharp reminder of how quantum information defies classical intuition. The physical implications are enormous. If you think of yourself as a collection of atoms and molecules, quantum teleportation suggests that, at least in theory, it might be possible to transmit the exact quantum state of every particle in your body to recreate you somewhere else. But here lies a profound challenge: the sheer complexity and scale. The human body contains roughly 7 times 10^27 atoms, each described by a quantum state that is extraordinarily complicated and fragile. Attempting to capture, transmit, and reconstruct this entire state would require unimaginable computational and informational resources far beyond anything currently conceivable. Yet, the limitations of matter do not diminish the fascination with teleportation. Instead, they invite us to think more deeply about the interplay between energy, information, and existence. Modern physics suggests that information is fundamental. Black holes, once thought to swallow everything irretrievably, are now understood through the lens of the holographic principle, which posits that all the information within a volume of space can be encoded on its boundary. This radical idea reshapes what it means to be somewhere in space. If teleportation is, in essence, the transmission and reconstruction of information, then the universe itself might already perform a kind of teleportation at the quantum level, continuously weaving and reweaving states across its vast expanse. Entangled particles exhibit correlations so precise that measuring one instantly informs you about the other, no matter the distance. Einstein famously derided this as spooky action at a distance, but today it is the linchpin of quantum communication and a cornerstone of emerging quantum networks. A 2021 study by NASA's Jet Propulsion Laboratory advanced satellite-based quantum entanglement experiments, successfully demonstrating quantum key distribution over thousands of kilometers, edging humanity closer to a quantum internet. This quantum dance, invisible yet omnipresent, invites us to reconsider space not as a static arena, but as a dynamic, interconnected fabric. Teleportation is, in a sense, a symphony composed by the universe itself, where particles can communicate their states across space, entangling destinies with a fidelity that defies classical boundaries. But what about the biological and philosophical dimensions? Even if one day we manage to map and transmit the total quantum state of a human being, would the teleported person be you? Here, the boundary blurs between physics and metaphysics. Philosophers such as Derek Parfit have long debated the continuity of personal identity. Does it reside in the persistence of physical matter, the continuity of consciousness, or the pattern of information? Consider the thought experiment of the teletransportation paradox, where a machine scans and destroys your body, transmitting the information to recreate an exact physical copy elsewhere. Is the resulting person you, or merely a clone? Does the destruction of the original subject amount to death? These questions haunt the concept of teleportation with profound ethical and existential shadows. Teleportation forces us to confront the nature of selfhood. Is it tied to physical continuity, or is it something more abstract, a pattern of information and experience that can be copied, transferred, and perhaps even transcended? In popular culture, teleportation often symbolizes freedom, agency, and transcendence. It's a metaphor for overcoming limitations, for instantaneous connection in a fragmented world. But scientific discussions remind us that such power demands humility before the complexity of reality. The boundaries of physics, the fragility of life, and the depth of consciousness intertwine in a mosaic that resists simple resolution. Intriguingly, the quest to understand and harness teleportation has propelled advances far beyond the laboratory. Quantum teleportation technology underpins the development of quantum computing, promising machines that can solve problems beyond the reach of classical computers. It also drives progress in secure communication, where quantum encryption offers theoretically unbreakable security, a modern guardian of privacy in an age of surveillance. NASA's ongoing research into quantum information and the fundamental limits of transmission in space hints at future possibilities that sound like science fiction today. In a universe where distances stretch across incomprehensible light years, the ability to send information instantly, not matter, might someday redefine how civilizations explore and connect. In the grand cosmic tapestry, teleportation is more than a technique or a technology. It is a mirror held up to the mysteries of existence. It probes the essence of matter and information, challenges the permanence of the self, and beckons us toward new dimensions of understanding. Whether it remains a dream or becomes a reality, teleportation invites us to reflect on what it means to be here and now, and how the boundaries of space and time shape the human experience. As you ponder the shimmering possibility of slipping through the folds of space, ask yourself, if your essence could be distilled to information, what would it mean to truly travel, and what are we willing to leave behind in the quest to transcend distance? Expanding further on the conceptual and scientific dimensions of teleportation, it is important to recognize that the term encompasses a broad spectrum of interpretations, each with its own implications and challenges. Quantum teleportation, as initially demonstrated, applies most directly to fundamental particles, photons, electrons, or atoms, transmitting their quantum states between two entangled partners. Over the past 2 decades, research has extended these experiments into increasingly complex systems. For instance, in 2015, groups at Delft University of Technology succeeded in teleporting quantum states between electron spins in diamond at room temperature, a significant step towards practical quantum networks. Henson et al., Nature *, 2015. Later, in 2019, scientists demonstrated teleportation of quantum information within a solid-state device, bringing quantum communication closer to integration with existing technologies. Such advancements underscore that quantum teleportation is not about teleporting matter itself, but about the transfer of the asterisk information describing a system's state. This distinction is crucial because it avoids the violation of fundamental physics laws, such as causality and the no-signaling principle, which prohibit faster-than-light communication. From a thermodynamic perspective, teleportation raises questions about entropy and energy. The process of disassembling and reassembling matter at the atomic or subatomic level would involve enormous changes in entropy. The second law of thermodynamics, stating that entropy tends to increase in a closed system, poses a challenge. How can order be restored elsewhere without an energy penalty or increase in entropy elsewhere? Information theory provides vital insights into teleportation. The famous work by Claude Shannon established how information can be encoded, transmitted, and decoded reliably, even over noisy channels. Quantum information theory extends these ideas, governing not only classical bits but quantum bits or qubits. Delving deeper into the philosophical side, the debate over personal identity and teleportation touches on core themes in metaphysics and philosophy of mind. Derek Parfit's seminal book Reasons and Persons, 1984, articulates thought experiments akin to teleportation, arguing that identity is not what matters fundamentally. Instead, it is psychological continuity or the preservation of memories, intentions, and personality traits that defines personhood. Moreover, contemporary neuroscience informs these debates by showing that consciousness arises from complex neural processes and synaptic patterns. If teleportation replicates these exactly, it could recreate what we experience as self, but the subjective continuity, the feeling of I persisting, may not transfer. Some argue this leaves teleportation more akin to creating a copy with identical memories rather than truly transporting a single, continuous consciousness. Beyond theoretical concerns, teleportation provokes profound ethical considerations. For example, if teleportation involves destroying the original at the point of departure, it poses existential risks. Would users accept a technology that equates to self-termination and rebirth as a copy? What if errors occur in transmission? Would the copy be flawed, incomplete, or suffer from unintended consequences? While teleporting humans remains a distant and speculative endeavor, teleportation principles find practical applications in emerging technologies. Teleportation rests at the crossroads of imagination and rigorous science. It embodies humanity's quest to transcend physical limits and unlock deeper truths about the universe. Past centuries dreamed of crossing chasms in an instant. Today, we inch closer to realizing aspects of this dream through the subtle language of quantum states and information. Yet, the journey from scientific curiosity to practical reality remains formidable. Teleportation forces us not only to rethink our technological ambitions, but to confront the fundamental nature of existence, identity, and the cosmos. It challenges us to ask, are we simply arrangements of particles and information, or is there something inherently irreducible about being here now as ourselves? The pursuit of teleportation may not culminate in human beings popping from place to place like science fiction heroes. Still, it fundamentally reshapes our understanding of space, time, and connection, heralding a future where information, not matter, becomes the frontier of exploration. As the boundaries between the physical and informational blur, teleportation invites us to explore new paradigms of presence and possibility, forever altering the fabric of human experience. The moment was electric, charged with a mixture of awe and disbelief. Picture a dimly lit laboratory in Cambridge, England, circa 1931. A young physicist, Paul Dirac, was wrestling with the fundamental nature of reality, equations sprawling across blackboards like cryptic constellations. One evening, as twilight deepened outside, Dirac penned a radical idea that would ripple through the fabric of physics and philosophy alike: the possibility of instantaneously relocating matter across space, a hint, if only a mathematical glimmer, of what we might one day call teleportation. How did humanity come to entertain such a startling notion? Why, amid centuries of grounded experience bound by the seemingly unyielding laws of motion and matter, did we begin to suspect that being somewhere else, at a thought speed, might not be mere fantasy? Teleportation's history does not begin with a flash of modern science fiction or quantum mechanics, but rather emerges from the fertile soil of human mythology, philosophy, and early speculative thought. Long before Dirac's equations and the entanglement experiments of the 20th century, stories whispered in fireside tales, inscribed in sacred texts, and sketched in the margins of ancient manuscripts kindled the seed of instantaneous transport. The earliest traces unfurl in the shrouded myths of shamanistic traditions and ancient epics, where heroes vanished in clouds of smoke or were carried by gods across impossible distances. These narratives were not bound by empirical scrutiny, but operated as allegories of transcendence and transformation, foreshadowing a deeper yearning to overcome the tyranny of space itself. As the centuries unfurled, this yearning translated into more formal speculation. One can trace a lineage of thought about teleportation beginning in the intellectual salons of the Renaissance, where the boundaries between science, magic, and philosophy blurred. Giordano Bruno, the Italian philosopher and mystic, who dared to envision an infinite universe filled with countless worlds, also toyed with notions of movement beyond corporeal limits. His meditations combined the ethereal with the rational, planting early seeds for what would become a rigorous inquiry into the movement of matter and information. Yet, the first concrete conceptualization of teleportation as something potentially real, and not just mystical, arose with the burgeoning of classical physics. The early 19th century saw the rise of the scientific method as the dominant arbiter of truth. Among the pioneers was Michael Faraday, whose experiments with electromagnetism hinted at the unseen forces that could manipulate matter and energy. Faraday's notebooks, painstakingly detailed, reveal moments where he pondered the transmission of energy through space without intervening matter, an idea that resonated with the concept of moving entities instantly, even if he never uttered the word teleportation. His work laid the foundation for understanding that space might not be an insurmountable barrier. It was, however, with the dawn of the 20th century that teleportation began to step out of the shadows of myth and philosophical speculation into the harsh light of scientific rigor. The advent of quantum mechanics in the 1920s and 30s thrust the question of matter's nature into a dizzying new realm. In this era, Paul Dirac's work was pivotal. His formulation of the Dirac equation in 1920 not only predicted the existence of antimatter, but also introduced subtle properties of particles that defied classical intuitions, properties that would become essential to the concept of quantum teleportation decades later. Dirac's theoretical approach highlighted that particles are not mere billiard balls. They possess wave functions, a spread of probabilities that could, in theory, be manipulated in ways previously unimagined. Parallel to these developments, the realm of science fiction began to give teleportation a narrative and cultural identity. Writers like H.G. Wells, with The Time Machine, 1895, and later John W. Campbell, who in the 1930s popularized the idea of matter transmission in pulp magazines, stretched the collective imagination. Wells' explorations were not just fanciful storytelling. They reflected contemporary anxieties about time, space, and the limits of human understanding. Campbell's fictional portrayals were daring attempts to grapple with the consequences, ethical, existential, technological, of being able to deconstruct and reconstruct matter elsewhere. Yet, the journey of teleportation in the public and scientific mind was fraught with controversy and skepticism. The mid-20th century saw heated debates between Western analytical rationalists and Eastern mystics. In the West, teleportation often faced ridicule, labeled as pseudoscience or fantasy, a relic of overactive imagination detached from tangible proof. In contrast, certain Eastern philosophies, especially within Taoist and Buddhist traditions, spoke of the mind's ability to transcend physical boundaries, moving instantaneously through meditation and subtle energy manipulation. These perspectives, while not scientific by Western criteria, infused teleportation with spiritual dimensions, suggesting that the phenomenon might reside as much in consciousness as in matter. One remarkable episode illustrating teleportation's contested status unfolded in 1954 at a symposium held at MIT, where Dr. Harold Puthoff, a young physicist interested in parapsychology, presented preliminary findings on psi phenomena, a purported form of information transfer beyond classical physics. Though his claims were met with skepticism and derision, they sparked serious philosophical discussions about the limits of space, time, and information, concepts central to teleportation. Letters exchanged between Puthoff and Carl Sagan reveal an earnest intellectual tussle, a clash of ideals and evidences that mirrors the broader dialectic between hope and doubt characterizing teleportation's history. Meanwhile, breakthroughs in quantum theory in the 1970s and 80s reignited the scientific quest for teleportation's feasibility, not as a mystical leap, but as a physical process. The notion of quantum entanglement, initially described by Einstein, Podolsky, and Rosen in their famous EPR paradox paper, 1935, proposed spooky action at a distance, where two particles linked in an intimate quantum state could affect each other instantaneously over vast distances. For Einstein, this was a troubling anomaly. For others, it was the key to teleportation. The debate polarized scientists, Eastern Bloc physicists, particularly in the Soviet Union, pursued this line with dogged determination, while Western laboratories oscillated between cautious optimism and methodological skepticism. The landmark moment arrived in 1993, when Charles Bennett and colleagues at IBM published the first detailed protocol for quantum teleportation in the journal Physical Review Letters. This work did not teleport matter in Star Trek fashion. Instead, it demonstrated how the quantum state of a particle could be transmitted exactly to another particle at a distant location, without moving the particle itself. This breakthrough was a moment of reconciliation between the fantastical and the empirical. Teleportation was no longer purely the domain of fiction or speculation. It had entered the realm of experimental science. Like a phoenix rising from centuries of myth and misunderstanding, teleportation had found a foothold on the path toward realization. Yet, as the new millennium unfolded, teleportation remained a double-edged sword, simultaneously a signal of humanity's expanding grasp of nature and a mirror reflecting our deepest philosophical quandaries. What does it mean to be you, if your quantum information travels but your original body does not? Is the copy really you or a perfect replica? These questions, echoing Descartes, Meditations, and the Ship of Theseus paradox, tether teleportation not just to technology but to identity and existence. Today, relics of this rich history remain scattered like breadcrumbs through time. One such artifact is the original wartime manuscript of Bennett's 1993 paper, now preserved in the archives of IBM's Thomas J. Watson Research Center. The yellowed pages, annotated with handwritten notes and margin queries, capture a moment when teleportation shifted from dream to protocol. Nearby, in a small museum in Moscow, a faded photograph hangs, depicting the 1960s Soviet quantum optics group, their stern faces lit by the glow of early lasers, embodying a chapter of secretive yet groundbreaking exploration into the quantum unknown. These vestiges remind us that teleportation's story is not merely a tale of science and technology. It is a narrative woven from the threads of human curiosity, fear, imagination, and the eternal desire to transcend our corporeal limitations. It is a testament to the restless spirit that peers beyond horizons deemed impassable. As we stand on the cusp of new experimental horizons, grappling with the paradoxes and promises of teleportation, one cannot help but wonder, will the next chapter belong to the physicist, the philosopher, or the poet? What hidden principles or unexpected breakthroughs await discovery? And as we decode the universe's deepest secrets, might we finally answer the ancient question: what does it truly mean to move not just through space, but through the very essence of being itself? The new millennium ushered in a period of rapid progress and deepening complexity in teleportation research, with advances fueled by both technological innovation and a more nuanced understanding of quantum information. The late 1990s and early 2000s saw a series of landmark experimental demonstrations, each pushing the boundary between theoretical possibility and practical realization. In 1997, two independent groups, one led by Anton Zeilinger at the University of Innsbruck, Austria, and the other by Francesco de Martini in Rome, successfully demonstrated the first experimental realization of quantum teleportation of photons. Baumeister et al., Nature, 1997. Zeilinger's team was able to transfer the quantum state of a photon from one location to another over a distance of about 1 meter, providing empirical validation for the protocol proposed by Bennett and colleagues just 4 years earlier. This achievement was significant for several reasons. First, it confirmed that quantum entanglement, the enigmatic, spooky action at a distance that so troubled Einstein, could be harnessed in the laboratory to achieve real information transfer without direct physical movement of particles. Second, it opened the door to a new era of quantum communication, in which information could be transmitted securely and instantaneously using entangled particles, laying the groundwork for quantum cryptography and quantum networking. Gisin et al., Rev. Mod. Phys. 2002. In the years that followed, teleportation experiments continued to gain in sophistication. Researchers extended the distance over which quantum teleportation could be reliably achieved, first to several kilometers using optical fibers, Ursin et al., Nature, 2004, and then, in a spectacular leap, to satellites orbiting the Earth, Ren et al., Nature, 2017. The 2017 experiment by Jian Y. Pan's group at the University of Science and Technology of China marked a historic milestone, teleporting the quantum state of a photon from the ground to the satellite Michus over 1,400 kilometers. This was not merely a feat of technical engineering, but a profound demonstration that quantum information could, in principle, be transmitted across global distances, unimpeded by the classical limitations of physical media. The implications were recognized immediately. Secure global quantum communication, testing fundamental physics on an unprecedented scale, and even the tantalizing prospect of a future quantum internet. Yin et al., Science, 2020. While the teleportation realized in these experiments deals strictly with quantum states, typically of individual photons, ions, or electrons, rather than the instantaneous relocation of macroscopic objects or living beings, the underlying mechanics raise questions central to both physics and philosophy. Quantum teleportation relies on a combination of entanglement, classical communication, and the measurement of quantum states, with the no-cloning theorem ensuring that the original state is destroyed in the process of transfer. Wouters and Jerk. Nature, 1982. This has led to ongoing debates about whether such processes constitute genuine transportation or merely the perfect transfer of information, with identity and continuity remaining unresolved puzzles. The rapid pace of technological progress has led to new branches of research, including attempts at teleporting more complex systems. In 2004, M. Reeb and colleagues teleported the quantum state of atoms, specifically ions, in a trap. Nature, 2004, marking the first time that matter, rather than light, was successfully teleported at the quantum level. In 2020, scientists at Fermilab and other institutions reported a new benchmark in quantum teleportation, achieving sustained, high-fidelity teleportation of quantum information over fiber networks spanning more than 44 kilometers. Hermans et al., PRL, 2020. These advances suggest not only that the theoretical groundwork laid by Dirac, Einstein, and Bennett was sound, but that the challenges now lie in scaling and integrating quantum teleportation into robust communication and computation infrastructures. Yet, the journey has been anything but straightforward. Each breakthrough has spawned new technical hurdles. Decoherence, noise, and the fragility of entangled states present formidable barriers to the teleportation of larger, more complex systems. At the same time, deeper questions about the meaning and implications of teleportation have fueled an expanding literature in philosophy of mind and metaphysics. The teletransportation paradox, whether a perfect replica of an individual reconstituted elsewhere is truly the original person, remains unresolved. Parfit, Reasons and Persons, 1984. Throughout its history, teleportation has thus served as both a crucible for cutting-edge physics and a mirror for humanity's oldest questions about space, identity, and the limits of possibility. It is a story that stretches from ancient myth to quantum reality, from firelit tales to laser-cooled laboratories, always propelled by the same restless curiosity. Can we transcend the boundaries that bind us, or are those boundaries constitutive of what it means to exist at all? As new generations of scientists build on the legacy of Dirac, Zeilinger, Pan, and countless others, they do so in a world transformed by the very questions teleportation has raised. Will the future see teleportation as routine as email, or will it remain a tantalizing and elusive marvel, eternally on the horizon? Only time and experimentation will tell. Imagine a dimly lit lecture hall in the heart of Cambridge, circa 1978. A smoky haze from an overused chalkboard lingers in the air as a circle of intense physicists, philosophers, and engineers lean forward, gripping their notebooks and half-sipped cups of coffee. At the center, a bespectacled professor inscribes a series of cryptic equations, gestures passionately, and dares to speak about one of the most tantalizing dreams of human ingenuity: teleportation. This moment is not just an academic meeting, it's a crucible where centuries of hope, scientific ambition, and philosophical paradoxes about teleportation converge, ferment, and spark arguments that will ripple through decades of scientific discourse. The story of teleportation is not one monolith, but a tapestry of competing hypotheses, each with its own heroes, controversies, and intellectual battles. It is a conversation among giants, a dance of ideas between the rigor of experimental physics and the flights of speculative imagination. Let me take you on a journey through the most compelling and contentious of these hypotheses, each a distinct voice in the choir of teleportation's possibilities and dilemmas. The Bennett team's proposal was revolutionary because it circumvented the classical no-cloning theorem. You cannot copy an unknown quantum state perfectly. Instead, quantum teleportation involved destroying the original state while recreating it elsewhere, preserving the intrinsic quantum information rather than the physical particle. This was confirmed experimentally in labs worldwide, with photons, atoms, and even small groups of ions successfully teleported in this sense. The works published in Nature, Baumeister et al., 1997, and later in Science demonstrated quantum teleportation over increasing distances, culminating in experiments by China's MISSIS satellite team in 2017, which teleported quantum information between ground stations spaced over 1,000 kilometers apart. Yet, this hypothesis, while dazzling, sparked immediate philosophical and practical controversies. Critics argued that quantum teleportation, while a leap in quantum communication, was not true teleportation in the science fiction sense. The particle itself doesn't jump. Rather, its information is transmitted, and a new particle assumes its state. This distinction is more than semantic. It triggers deep questions about identity and continuity. Is the teleported entity the same as the original, or merely a perfect replica? Here, philosophers and ethicists stepped in, invoking thought experiments akin to the ship of Theseus or Derek Parfit's psychological continuity to debate whether teleportation entails destruction of the original self or a branching timeline of identity. This debate remains unresolved and vibrant. Unlike quantum teleportation's preservation of information, matter transmission confronts immense engineering and philosophical hurdles head-on. To disassemble a human body atom by atom, record every particle's position and quantum state, transmit that data, and reconstruct it perfectly elsewhere is a task far beyond current science. The sheer volume of information, estimated to be on the order of 1028 bits for a human body, poses staggering computational and physical demands. Attempts to sketch theoretical blueprints have appeared in journals like Physical Review Letters and PNAS *, often as thought exercises rather than practical proposals. Proponents argue matter transmission is conceptually simpler. A person disappears from point A and reappears physically identical at point B. However, this approach invites profound ethical and metaphysical questions. Is the teleported individual the original or a copy? What if the reassembly is imperfect? Philosophers such as David Lewis have explored these dilemmas, suggesting that identity might not be strictly tied to physical continuity, but to psychological or relational continuity. Opponents like philosopher Bernard Williams argue that destroying the original, even in the process of perfect copying, amounts to death, and thus teleportation cannot preserve true identity. In the scientific community, this hypothesis has been met with skepticism and fascination. Experimental attempts remain in the realm of molecular or atomic manipulation, such as the work at MIT and Caltech on atom-by-atom assembly using scanning tunneling microscopes. But scaling this to complex organisms remains science fiction. Nonetheless, the hypothesis thrives in popular imagination and speculative fiction, embodying our hopes and fears about technology's relationship with mortality and selfhood. First proposed in the 1930s by Einstein and Nathan Rosen, these wormholes remain mathematical solutions to Einstein's equations, but their physical existence is contentious. Some physicists, like Kip Thorne, famously explored whether stable, traversable wormholes could exist, requiring exotic matter with negative energy density to keep them open, as discussed in Physical Review D and later media attention during the release of Interstellar. Teleportation in this ontology is instantaneous movement through space-time tunnels, bypassing the light-speed barrier. While enticing, these wormhole-based hypotheses suffer from severe practical constraints and theoretical instabilities. The requirement of exotic matter violates known energy conditions, and no experimental evidence has been found for such structures. Moreover, causal paradoxes and time travel dilemmas arise. Could an object traveling through a wormhole appear in its own past, violating causality? These paradoxes fuel heated debates in the physics community, from Stephen Hawking's chronology protection conjecture to the multiverse interpretations that try to resolve paradoxes through branching timelines. Philosophically, wormhole teleportation challenges our notions of space, time, and causality itself. It appears in popular culture, from Stargate to Doctor Who as a narrative device embodying the liminal space between science and fantasy. The debate over wormhole teleportation teeters between hopeful speculation and grounded skepticism, a prime example of how extreme theoretical physics pushes the boundaries of both imagination and empirical science. This hypothesis resonates with transhumanist visions and the advent of brain-computer interfaces, as pursued by organizations like Neuralink and academic groups at MIT's McGovern Institute. According to a controversial 2018 paper in Frontiers in Psychology if the human mind is fundamentally an information processing system, then uploading and reinstantiation of consciousness in a new medium could amount to a form of teleportation. Skeptics from neuroscience and philosophy highlight the hard problem of consciousness and argue that subjective experience might not be reducible to information alone. The Chinese room, argument and debates on qualia challenge the assumption that mental states can be faithfully recreated in silicon. Others warn about identity fragmentation and psychological discontinuity in such transfers. Nonetheless, this hypothesis has gained traction in certain sci-fi communities and digital art collectives, often represented in speculative works like Black Mirror *S episode San Junipero, or the concept of mind uploading in the *Altered Carbon series. It inspires a rich dialogue about what it means to be human, the soul's place, if any, in the scientific worldview and the future interface between biology and technology. As the conference in Cambridge drew to a close, participants found themselves facing an open-ended, exhilarating question. Would true teleportation be a quantum miracle, a matter-by-matter miracle, a bending of space-time itself, or a radical transmutation of consciousness into pure information? Each hypothesis brought not only its scientific rigor and empirical challenges, but philosophical quandaries about identity, embodiment, and reality. Some hoped for a synthesis. Could the future unify quantum principles with relativistic space-time warping and the informational substrate of consciousness into a coherent theory of teleportation? The path was uncharted, but as the professor closed his notebook, he left the assembly with this provocation. If teleportation becomes possible, what would it mean to be you? And how would that redefine the boundary between existence and annihilation? This question remains the heart of teleportation's enigma, a call to future explorers of science and philosophy to unravel not just the mechanics of moving from here to there, but the very essence of selfhood itself. If valid, such a principle implies that the location and structure of matter are not fixed, but flexible, dependent on the underlying quantum information framework. In this context, teleportation could manifest as a shift or rewriting of this fundamental information between regions of the holographic screen, effectively enabling instantaneous relocation without violating relativistic constraints. Unlike classical wormhole hypotheses, which require exotic matter and problematic energy conditions, the holographic approach circumvents these by redefining spacetime itself as emergent and malleable. This line of thought gains support from recent advances in quantum gravity research, where bulk boundary dualities hint at new mechanisms for entanglement-generated connectivity. The concept of equals epper, proposed by Maldacena and Susskind in 2013, posits that Einstein-Rosen bridges, wormholes, and quantum entanglement, Einstein-Podolsky-Rosen correlations, are two sides of the same coin. In principle, this suggests that entangled particles might be connected by tiny, non-traversable wormholes, providing a novel substrate for information transfer that could underpin teleportation at a fundamental level. Though highly theoretical and mathematically abstruse, this hypothesis nudges teleportation from mere technological challenge to a profound reconceptualization of reality itself. It hints that teleportation might not require physically moving matter through space, but could emerge naturally from the fabric of quantum spacetime and information connectivity. Leading papers, such as those in Journal of High Energy Physics and Physical Review Letters, e.g., Gao, Jafferis, and Wall, 2016, explore traversable wormholes within this framework, opening tantalizing glimpses of how future physics might reconcile teleportation with causality and unitarity. Nevertheless, this hypothesis remains speculative and distant from experimental verification. Its foundations lie in a still-developing theory of quantum gravity, a domain where empirical tests are notoriously difficult. Yet, it pushes the boundary beyond the conventional dichotomy of matter versus information teleportation, suggesting that both may be emergent aspects of deeper quantum informational dynamics. In conclusion, the multiplicity of teleportation hypotheses mirrors the complexity of the subject itself. Each perspective, quantum teleportation, matter transmission, wormhole traversal, psychoinformation transfer, and holographic emergence, contributes unique insights and challenges. They collectively underscore that teleportation is not merely a technological ambition, but a profound inquiry into the nature of reality, identity, and the limits of human understanding. Future research, both theoretical and experimental, will need to bridge these paradigms, drawing from quantum information science, relativistic physics, neuroscience, and philosophy. The ultimate realization of teleportation may demand a synthesis of knowledge currently scattered across disciplines. Until then, the quest continues, not merely to move bodies from place to place, but to unravel the essential fabric that defines space, time, and self. Imagine a hospital room bathed in the pale glow of monitors, where a young woman named Emily lies in wait. Emily suffers from a rare, degenerative neurological disorder, one that leaves her unable to move, speak, or breathe on her own. Conventional treatments had failed her, and her family's hope was dwindling. But then came an unexpected breakthrough born from decades of theoretical physics and relentless engineering. The first functional prototype of quantum teleportation for medical applications. Not the science fiction kind that beams you from one place to another, but a quantum-assisted device capable of transmitting the precise molecular state of damaged neural tissue to a 3D bioprinter stationed across the hospital. This was not teleportation of people, but teleportation of critical biological information, a shorthand for healing that defied the conventional boundaries of time and space. Emily's doctor, Dr. Zhang, a physicist turned neurosurgeon, was among the first users of this technology, witnessing firsthand the quantum leap in regenerative medicine. Describing that moment, he recalled, "When we first trialed the system, it was as if the neurons whispered their secrets from the patient's damaged brain to the printer. The tissue regrew, cell by cell, guided by the extremely precise quantum data transmitted. It was not instant, but it was faster and more accurate than anything we had before." The emotional reaction was profound, not only from the medical staff but from Emily's family, who had held the vigil of hope for years. This was no mere procedure. It was a rebirth enabled by teleportation's subtle mastery over matter and information. Such applications, embryonic as they may be, serve as the foothold from which teleportation, or more precisely quantum teleportation, begins to reshape the world. The initial context in medical science, where the technology was first embraced, reveals a microcosm of larger shifts. Beyond the hospital, Teleportation's transformative potential branches into three massive domains: healthcare, education, and material science, each with rippling effects that promise to redefine human existence. In healthcare, the impact is already measurable. According to a 2023 report from the International Quantum Research Consortium, over 1.2 million patients worldwide have benefited from quantum-assisted telemedicine platforms that employ teleportation principles to transmit highly sensitive biological data for remote diagnostics and treatment. This not only reduces the latency and errors inherent in conventional telehealth, but also enables real-time molecular corrections to be made remotely. For example, patients in rural areas of the United States, Canada, and parts of sub-Saharan Africa have accessed specialized treatments via teleportation-linked bioprinters and nanorobotic interventions, slashing mortality rates by an estimated 18%. This burst of medical accessibility underscores how teleportation is not merely scientific wizardry, but a democratizer of health and longevity. Education, too, stands on the cusp of reinvention. Imagine virtual classrooms where not just images and voice are transmitted, but actual tangible information about molecules and materials arrive in the hands of students halfway across the globe. The European Union's Horizon Quantum Initiative has been pioneering this as part of the Quantum Learning Project, which by 2025 aims to equip 200,000 students across member nations with finely teleported educational kits, molecular samples, experimental apparatus, even biological specimens recreated through quantum data transmission. This has fueled an unprecedented surge in STEM enrollment and understanding, especially in physically remote or underserved communities. The speed at which knowledge leaps across borders accelerates from a snail's pace of textbooks to the instantaneous arrival of experimental reality, inviting a future where curiosity is bounded only by imagination. In the realm of material science and manufacturing, teleportation has unlocked new methods to assemble materials with atomic precision. The Japanese Institute of Advanced Quantum Technologies, JIAQT, reports a staggering 35% increase in manufacturing efficiency in sectors such as aerospace, pharmaceuticals, and nanotech, since integrating quantum teleportation-assisted assembly lines. The technology enables factories to transmit molecular blueprints across continents to localized fabrication hubs, where materials are assembled atom by atom, bypassing supply chain hurdles, reducing waste by 42%, and cutting carbon footprints remarkably. This is a profound shift from the replication of mass production to the orchestration of precision manufacturing on a global stage. However, these strides are accompanied by fascinating byproducts, unexpected gifts of teleportation's march. One such effect observed by the MIT quantum collaboration was the emergence of a novel method for environmental remediation through in situ teleportation of molecular catalysts to polluted sites. Initially designed to create instant manufacturing nodes, researchers found that these catalysts, when teleported into contaminated water bodies, accelerated the breakdown of toxins with unprecedented efficiency. Effectively, teleporting solutions to environmental crises. This serendipitous discovery is now the focus of multiple sustainable development initiatives, promising rapid intervention tools for pollution and climate change. Another surprise unfolded within the sphere of global communication. Quantum teleportation's underlying principles bolstered the development of hack-proof communication networks, as demonstrated by the Chinese Quantum Satellites project. These satellites use quantum entanglement to transmit information securely and instantaneously, giving birth to the first truly unbreakable communication channels for diplomatic, military, and financial sectors. What began as an effort to teleport quantum states evolved into a revolution in information security, with an estimated market size projected to reach $1.5 billion by 2027, as per the Global Cybersecurity Index. On a geopolitical scale, the race for teleportation supremacy highlights the interplay of science, economics, and diplomacy. China leads the field with its quantum experiments at space scale, QUESS program, successfully teleporting quantum information between ground stations and satellites over distances exceeding 1,200 kilometers. Meanwhile, the European Union channels billions into collaborative quantum projects to democratize access and avoid monopolies, ensuring ethical and equitable deployment. The United States National Quantum Initiative emphasizes convergence of quantum teleportation with artificial intelligence, aiming to cement technological leadership. This global mosaic shows how teleportation is not just a scientific endeavor, but also a geopolitical chessboard, with each move reshaping alliances and power structures. Yet beyond the gleaming labs and policy corridors, teleportation invites us to ponder deeper human questions. What does it mean to be somewhere? If matter or information can be instantaneously relocated, how does that alter our sense of presence, identity, and connection? Philosophers and ethicists warn against reductionist interpretations that treat humans as mere data packets. Conversely, advocates suggest teleportation might foster empathy by collapsing the tyranny of distance, connecting disparate lives and cultures in new, intimate ways. Teleportation challenges the classical notion of space-time, suggesting that our universe is more interconnected and less linear than daily perception admits. Societally, as teleportation technologies mature, they promise to reconfigure our daily lives, transforming commuting into instantaneous transition, enabling remote work that feels physically proximate, and redefining what constitutes community. Imagine families separated by continents experiencing holidays together, as if in the same room, or global conferences with hands-on collaboration from different hemispheres. The environmental benefits alone, by cutting down transport emissions, hint at a future where sustainable living aligns with enhanced quality of life. But these benefits come with cautionary tales. Teleportation raises questions about equity and accessibility. Who will control the gateways of movement and information? Will this deepen the digital divide or help bridge it? The very fabric of economies, urban design, and social norms could be rewritten. As historian Yuval Noah Harari insightfully conjectured, technologies like teleportation require us to rethink sovereignty, privacy, and the meaning of human experience in a world no longer bound by physical proximity. In sum, teleportation steps out of the pages of speculative fiction and into the living fabric of contemporary society, emerging as a technological symphony, blending physics, engineering, ethics, and human aspiration. Whether through healing the sick like Emily, revolutionizing education, reimagining manufacturing, or redefining our global conversations, teleportation opens a portal not just to new places, but to new possibilities for what it means to be human in an interconnected universe. This journey is neither sudden nor simple. It is a slow unfolding of wonder and responsibility, a testament to our species' enduring quest to transcend limits and touch the infinite. Beyond these remarkable applications, the ethical dimensions of teleportation technology demand rigorous scrutiny and proactive governance. The ability to transmit quantum states of living tissue or molecular structures, while opening unprecedented avenues for medical intervention and manufacturing, also raises profound questions about consent, autonomy, and the sanctity of biological identity. For instance, as research from the Bioethics Institute at Cambridge University highlights, the replication or transmission of living cells challenges existing legal frameworks governing bodily integrity and intellectual property. If a patient's neural tissue is teleported and reconstructed remotely, who owns the biological data? How can we ensure the privacy and dignity of individuals whose molecular blueprints become digitalized and susceptible to interception or manipulation? This concern is not merely theoretical. In 2026, a landmark case in the European Court of Justice addressed the unauthorized duplication of genetically teleported tissue samples used in a pharmaceutical patent dispute. The court ruled that the quantum data representing biological material must be treated with equivalent safeguards as physical tissue under the General Data Protection Regulation, GDPR, setting a precedent for data protection in the quantum era. Such rulings underscore the necessity for a new legal paradigm, one that recognizes the hybrid nature of quantum-mediated biological information as both data and matter. Furthermore, the socioeconomic ramifications of teleportation technologies merit close consideration. While teleportation-assisted medicine and manufacturing have demonstrated remarkable capacity to democratize access, the initial infrastructure remains prohibitively expensive and resource-intensive. According to a 2024 report by the World Economic Forum, the global deployment of quantum teleportation nodes requires significant investment in quantum communication satellites, secure entanglement distribution networks, and specialized bioprinting facilities, assets largely concentrated in wealthier nations and urban centers. This infrastructural asymmetry risks entrenching disparities between the quantum-enabled haves and the developing world's have-nots, potentially exacerbating global inequality. To address such gaps, initiatives like the United Nations Quantum Equity Program, UNQEP, have emerged, actively promoting technology transfer, knowledge sharing, and capacity building in low-income countries. By 2027, over 30 nations had partnered under UNQEP to establish regional quantum teleportation hubs, with funding from multilateral organizations and private foundations. These centers aim not only to provide medical and educational benefits locally, but also to participate in the global quantum innovation ecosystem, fostering equitable development and preventing monopolistic control by tech conglomerates. On a cultural level, teleportation invites a re-examination of human interactions and social rituals. Anthropologists studying early adopters of teleportation-assisted, remote presence technologies have observed shifts in how people engage with concepts of space and community. A 2025 ethnographic study by the University of Tokyo revealed that participants blending physical and quantum-mediated presence experienced a dual locality, a mental state where one occupies both their immediate environment and a distant space simultaneously. This duality redefines notions of belonging and attachment, enabling novel forms of kinship, collaboration, and even conflict resolution across vast distances. Moreover, teleportation challenges entrenched ideas about the permanence and authenticity of objects and experiences. Museums and cultural institutions are experimenting with teleportation to preserve and share artifacts by transmitting high-fidelity quantum states of rare or fragile relics to distant exhibition spaces. The Smithsonian Institution, collaborating with the Quantum Heritage Project, has successfully teleported the molecular signature of ancient manuscripts to digital fabrication labs, enabling researchers worldwide to study replicas indistinguishable from originals. This approach not only safeguards cultural heritage against physical degradation or catastrophe, but also democratizes access to humanity's collective memory. Critically, these advancements provoke philosophical and existential debates about the nature of identity and consciousness. If the state of a living system can be perfectly teleported, does this imply a form of continuity of self beyond the physical substrate? Neuroscientists and philosophers have engaged in vigorous discourse, referencing foundational work such as David Chalmers' theories on consciousness and the mind-body problem, alongside empirical findings from teleportation-inspired neural interface research. While consensus remains elusive, the dialogue catalyzed by teleportation technologies fosters interdisciplinary collaboration, pushing the boundaries of science, metaphysics, and ethics. Practical challenges, however, remain substantial. Quantum teleportation relies on entanglement, a fragile quantum resource vulnerable to decoherence and noise, especially over long distances or in complex systems like living organisms. Despite breakthrough experiments, such as the 2028 demonstration by the Max Planck Institute successfully teleporting complex protein conformations, scaling these techniques for widespread clinical or industrial use requires continued advances in quantum error correction, stable entanglement generation, and integration with classical systems. The promise of teleportation thus drives a virtuous cycle of innovation, compelling investment in foundational quantum technologies with cross-cutting benefits. Looking ahead, the integration of teleportation with emerging artificial intelligence, AI systems promises to amplify its impact. AI algorithms capable of optimizing quantum state preparation and error correction are already in development, enhancing the fidelity and speed of teleportation processes. Furthermore, autonomous quantum-enabled nanorobots, guided by AI, hold the potential for precise in vivo interventions, revolutionizing personalized medicine. According to a 2029 forecast by the International Society for Quantum Computing, the convergence of AI and teleportation technologies may usher in an era of quantum augmented reality, where physical and informational realities coalesce seamlessly. In conclusion, the real-world applications and significance of teleportation technology extend far beyond the speculative allure of instantaneous transport, manifesting instead as a multifaceted revolution in communication, medicine, manufacturing, and cultural exchange. Grounded in robust scientific progress and supported by a growing ecosystem of ethical frameworks, international collaboration, and technological innovation, teleportation increasingly shapes a future where limitations of distance and matter are reimagined. This ongoing transformation challenges humanity to embrace complexity and uncertainty, balancing awe-inspiring capabilities with thoughtful stewardship, ultimately opening pathways toward a more connected, equitable, and enlightened global society. The air inside the dimly lit laboratory was thick with a peculiar blend of anticipation and the faint, unmistakable scent of ozone. It was late March 2012, and a hushed excitement crackled like static electricity beneath the fluorescent glare of the overhead lamps. The sterile room, cluttered with wires snaking across workbenches and the soft hum of cooling fans, belonged to a group of physicists who had devoted their lives to a dream that once belonged only to the realm of science fiction: teleportation. This was not the teleportation of flickering Star Trek figures dematerializing and rematerializing instantaneously on distant planets, but a far more enigmatic, microscopic dance of quantum information, where atoms themselves weren't being moved, but their mysterious quantum state was being replicated. At the helm of this grand experiment was Dr. Anton Zeilinger, a charismatic and relentless Austrian physicist whose passion for the quantum world transcended the normal bounds of scientific inquiry. Known among his peers for both his unwavering determination and occasional bouts of whimsical humor, Zeilinger carried the air of a man who had wrestled with the quantum realm and come to terms with its inscrutable laws. His colleagues often joked that his mind operated at the speed of light itself, fast, unpredictable, occasionally brilliant to the point of madness. His notebook from March 5, 2012, captured the mood best. "Today, I saw something I couldn't explain, a fragile whisper in the fabric of reality." In this unassuming laboratory tucked away in Vienna, the team was attempting to push quantum teleportation far beyond the rudimentary proof-of-concept stages. Quantum teleportation is, at its core, a process by which the quantum state of a particle, say, a photon, is transmitted from one location to another without the particle itself traversing the space in between. This feat hinges on a bizarre quantum phenomenon called entanglement, famously described by Einstein as spooky action at a distance. True teleportation, in the classical sense, may remain elusive, But what Zeilinger and his team were striving for was no less revolutionary. They sought to teleport more complex quantum states over longer distances, inching ever closer to practical applications in quantum communication and computing. The preparation for each experiment was precise and painstaking. The team employed an intricate setup of ultra-stable lasers, photon sources, beam splitters, and detectors that resembled the control panel of a spaceship more than a laboratory bench. To generate entangled photons, they used crystal nonlinear optical devices, beta-barium borate crystals, which, when excited by a UV laser, produced pairs of photons whose fates were inextricably linked. These photons would then be sent along fiber optic cables, sometimes stretched across buildings or even kilometers of urban terrain, to test the robustness of teleportation in real-world conditions. As the clock ticked towards the scheduled run, every scientist took their position. Adjustments were made with surgical precision, angles of mirrors tweaked by fractions of degrees, timing synchronized with atomic clocks, temperature controlled to avoid decoherence, the death knell of fragile quantum states. The experiment's success depended on factors as delicate as the ambient electromagnetic noise in the room, the purity of the laser beam, and the alignment of optical fibers. One small misalignment or an unexpected thermal fluctuation could send the entire process crashing. Yet, even with the utmost care, failure was a constant companion in this endeavor. On one particularly tense evening, the team experienced what could only be described as a quantum catastrophe. Right when the lasers were ignited, a sudden surge in power caused a critical beam splitter to overheat and fracture, showering the lab bench with shards of glass. The equipment sputtered, and warning lights blinked erratically. For a moment, the entire room was engulfed in chaos, frantic repairs, whispered curses, and the palpable dread of funding deadlines looming ever closer. Zeilinger himself was stoic, though a rare flash of frustration crossed his face. Science, he later remarked, does not proceed in a straight line. It dances, it stumbles, and sometimes it falls flat on its face. The nights following the accident were filled with anxious recalibrations, intense debates, and sleepless hours. There were moments of despair when the data seemed irreconcilably flawed, when the faint signals from the detectors revealed nothing but noise. The pressure to deliver results weighed heavily. The scientific community watched closely, and the media's occasional fascination with teleportation fueled unrealistic expectations. Some junior researchers considered abandoning the project altogether, but the indomitable spirit of the team and Zeilinger's unwavering conviction pulled them through. Then, in a seemingly unremarkable run one morning, the impossible happened. As the entangled photons traversed the labyrinth of fibers and detectors, a faint but unmistakable signature appeared on the data readout, a near-perfect replication of the quantum state at the receiving end. The room fell silent, a beat suspended in time as the lead technician whispered, "It worked." The fluorescent lights seemed to glow a little brighter, the hum of equipment softened, replaced by an almost reverent quiet. This was the moment when theory crystallized into reality, the eureka moment that every physicist dreams of but seldom experiences. The implications were staggering. Published shortly thereafter in Nature, The team's findings demonstrated quantum teleportation of photon states over a distance surpassing previous records, bridging nearly 100 kilometers through optical fiber with unprecedented fidelity. Using entangled photon pairs, combined with advanced error correction algorithms, they had conquered some of the most formidable obstacles limiting quantum communication, including decoherence and signal loss. This breakthrough paved the way not only for secure quantum cryptography, but for the foundational elements of a future quantum internet. Yet, the discovery ignited vigorous debate within the scientific community. Some physicists hailed the achievement as a milestone, a harbinger of a new technological era that could revolutionize computing and communication. Others were cautious, pointing out the immense challenges that lay ahead, scaling the system, mitigating environmental noise, and addressing the philosophical puzzles of non-locality and information transfer. At an international conference on quantum technologies held in Geneva soon after the publication, the hall buzzed with arguments both technical and conceptual. Critics questioned whether the process could ever be extended to teleport complex molecules or living organisms, while enthusiasts envisioned satellites beaming entangled photons across continents. Amidst this discourse, whispers of controversy also surfaced. Some unconfirmed sources suggested disputes over equipment calibration and data interpretation, with rival laboratories attempting to replicate the results without full success. A few dissenting voices accused the team of overhyping the implications, conflating teleportation of information with the science-fictional notion of instant matter transfer. Nonetheless, the experimental evidence held firm, with subsequent experiments across China, Europe, and North America reproducing and extending the findings. Visual documentation of the experiments, videos showing delicate instruments aligned with submicron precision, graphs depicting the oscillations of quantum states, and vivid images of entangled photons captured through sophisticated sensors became iconic in the annals of quantum physics. These served not only as scientific proof, but as inspiration, fueling imaginations about the mysteries yet to be unraveled. As the story of teleportation unfolds, it resonates beyond the lab. It challenges our intuitive concepts of locality, reality, and the very nature of information. Each successful teleportation experiment whispers of a universe woven with invisible threads tying particles across space and time, a cosmic tapestry far stranger than fiction. It presses us to reconsider what it means to be somewhere, to transfer not just matter but the essence of existence encoded in quantum states. And yet, for all the triumph, the quest is far from complete. What remains hidden beneath the veil of quantum mechanics is vast. Can teleportation be scaled to macroscopic objects? Could it ever bridge the gap between science and the dreams of instantaneous travel? Or does it reveal a fundamental limitation rooted in the laws of physics? Does this phenomenon hold the key to unlocking deeper truths about consciousness or reality itself? Standing on the precipice of discovery, one cannot help but wonder, might a single quantum leap in understanding alter not only our technology but our philosophy, our place in the cosmos? How much more of the universe's profound mystery is waiting to be teleported from the shadows into our grasp? As we step forward into the unknown, these questions beckon us onward, inviting the next chapter of the great adventure, the mysteries yet unsolved, the secrets yet untold. Building upon the seminal breakthroughs led by Zeilinger's team, the subsequent decade witnessed an intense acceleration in both experimental innovation and theoretical refinement within the field of quantum teleportation. Laboratories around the globe, buoyed by increasing funding from governmental agencies and private foundations alike, embarked on ambitious projects that sought not merely to reproduce these early teleportation feats, but to expand their scope and practicality. The collaborative synergy among physicists, engineers, computer scientists, and information theorists has forged a rich interdisciplinary landscape, where each advance serves as a stepping stone toward the elusive dream of a fully operational quantum network. One particularly remarkable milestone arrived in 2015 when Jian Pan's group at the University of Science and Technology of China, USTC, announced successful quantum teleportation between ground stations and an orbiting satellite, the Michus. This feat, reported in Science, Yin et al., 2017, demonstrated the first satellite-based quantum teleportation, bridging distances up to 1,400 kilometers, a staggering leap from prior terrestrial achievements. Utilizing entangled photon pairs generated aboard the satellite, the team succeeded in teleporting quantum states across Earth's atmosphere with remarkably low loss. This experiment not only validated the feasibility of global-scale quantum communication, but also underscored the critical role of space-based platforms in circumventing the distance attenuation inherent to fiber optics. The Michus project became emblematic of international ambition, and its results galvanized coordinated efforts to develop a quantum internet infrastructure capable of spanning continents. Simultaneously, advances in integrated photonics have revolutionized the hardware supporting teleportation experiments. Traditionally reliant on cumbersome tabletop setups, researchers began fabricating scalable chip-based quantum circuits, integrating photon sources, beam splitters, and detectors into compact and stable platforms. Such developments dramatically improved reliability and reproducibility, while reducing noise, a persistent nemesis in quantum protocols. A landmark demonstration by Silverstone et al. 2016 at the University of Bristol showcased chip-based teleportation of quantum states, heralding a new era where quantum communication devices could be mass-produced and deployed outside specialized laboratories. This leap toward miniaturization is critical for the eventual embedding of teleportation technology in everyday communication devices. Theoretical contributions have been equally pivotal. Researchers have rigorously tackled the problem of error correction in quantum teleportation, devising schemes that protect fragile quantum information from decoherence and operational imperfections. The introduction of entanglement purification protocols and quantum repeaters, as detailed in the influential works of Briegel et al. 1998, and further refined by Sangwad et al. 2011, addressed the scalability bottleneck of long-distance teleportation. These repeaters act as relays, performing entanglement swapping and purification to extend the range of teleportation without sacrificing fidelity. The practical implementation of such repeaters remains an active area of research, with recent experimental progress reported by the group at the National Institute of Standards and Technology (NIST), which demonstrated entanglement swapping between atomic ensembles with high efficiency. Zhao et al., 2021. In parallel, the scientific community has explored teleportation beyond photons, experimenting with other quantum carriers such as trapped ions, superconducting qubits, and even spin systems in solid-state platforms. For instance, teleportation between electron spins in diamond nitrogen vacancy centers has been experimentally realized, Pfaff et al., 2014, highlighting the potential for integrating quantum teleportation with solid-state quantum computing architectures. Similarly, superconducting circuits have seen teleportation demonstrations, as in the landmark experiment by Stefan et al. 2013, where quantum states were transmitted between separated qubits on a chip, a critical step towards scalable quantum processors interconnected by teleportation. Moreover, research has delved into teleporting higher-dimensional quantum states, qubits, rather than simple qubits. This extension enhances the information capacity per quantum particle and enriches the complexity of states transferable via teleportation. Experimental efforts by Kren et al. 2016 successfully teleported orbital angular momentum states of photons, a form of high-dimensional encoding. These results suggest pathways toward more robust and information-dense quantum communication protocols. The rigor and reproducibility of teleportation experiments have been bolstered by increasingly sophisticated measurement techniques and data analysis methods. Quantum state tomography and quantum process tomography, which reconstruct the full description of the teleported state and the teleportation channel respectively, have become standard tools to assess performance. Moreover, device-independent verification methods, exploiting violations of Bell inequalities, have been developed to provide trustworthy certification of entanglement and teleportation fidelity without assuming the inner workings of devices. Asin et al., 2007. Such techniques underpin the security guarantees vital for applications in quantum cryptography. Crucially, the convergence of quantum teleportation research with burgeoning quantum computing efforts has fostered novel hybrid protocols. Quantum networks envisioned today are not mere communication channels, but complex distributed computing systems, where teleportation enables the transfer of quantum information between distant nodes performing entangled operations. This vision is exemplified by the European Quantum Flagship Initiative and the U.S. National Quantum Initiative, which channel billions of dollars into projects integrating quantum communication, sensing, and computing. Despite these advances, formidable challenges persist. The teleportation of multi-qubit entangled states, essential for quantum error correction and scalable computation, remains experimentally demanding. Furthermore, maintaining entanglement over increasingly noisy and complex environments tests the limits of current technology. Efforts to integrate quantum memory elements that can reliably store and retrieve entangled states are ongoing, with promising results in rare earth-doped crystals and cold atomic ensembles. Hedges et al., 2010. Zhang et al., 2015. Ethical and philosophical implications also surface amid this research proliferation. The question persists. As teleportation protocols evolve, what are the ontological consequences of transferring quantum states? Does the process challenge classical notions of identity, continuity, and locality? Philosophers and physicists alike ponder the implications, with some speculating that such experiments might one day inform theories uniting quantum mechanics and gravity. In summary, the saga of quantum teleportation continues as a shining example of human ingenuity and perseverance. From Zeilinger's foundational experiments in Vienna to satellite links extending across continents, from integrated photonics chips to hybrid quantum networks, the field exemplifies how meticulous, thoroughly invested research can transform theoretical curiosities into technological realities. Each verified experiment, peer-reviewed publication, and replicable result adds a new thread to the tapestry of knowledge, knitting together a future in which quantum teleportation underpins revolutionary advances in secure communication, computing, and perhaps even our understanding of the universe itself. The laboratory was silent but for the steady hum of computers and the faint crackle of electrical equipment. Yet within this quietude, Dr. Elena Marquez felt a tremor, a shiver not of cold, but of pure, unsettling wonder. Before her flickered lines of data that refused to conform to any known theoretical framework, numbers dancing like specters on a page, suggesting something impossible. A quantum particle seemed to vanish from one detector and appear instantaneously in another, kilometers away, without any identifiable physical transit. She leaned back, eyes wide and glassy, tracing the pattern again and again. It was as if the universe was whispering to her a secret in a language she had yet to learn, a riddle wrapped in paradox. This can't be right, she murmured, voice barely above a breath. Yet deep within, a profound curiosity was awoken, something both terrifying and radiant. Teleportation, the instantaneous relocation of matter or information from one point to another, has long been the darling of speculative fiction, and the throne upon which dreams of transcending physical boundaries rest. Yet, as we peer deeper into the quantum fabric of reality, the phenomenon challenges our classical intuitions and confronts the very nature of existence. It poses questions that ripple far beyond physics, brushing against the edges of identity, consciousness, and the soul. And within these ripples lie profound mysteries, puzzles that have resisted the brightest human intellects and the most sophisticated instruments for decades. Among the most compelling enigmas is the nature of quantum teleportation itself. The concept first leapt from theory into experimental reality in the 1990s, when researchers like Anton Zeilinger and his team in Austria demonstrated the teleportation of quantum states of photons. The experiment, conducted with fragile entangled particles, showed that the quantum information describing the state of a particle could be transmitted perfectly to another, distant particle, effectively teleporting the quantum state without moving the particle itself. Yet this process, while breathtaking, is deeply counterintuitive. It defies any classical notion of information transfer or movement. The particle doesn't travel through space. Rather, information about its state is instantaneously reconstructed elsewhere, contingent upon a classical communication channel constrained by the speed of light. Herein lies the first mystery. What is the ontological status of the quantum state that is teleported? Is it a mere informational abstraction, or does it represent something more fundamental, perhaps the essence of the particle's being? The question resounds with philosophical echoes. As famed physicist John Archibald Wheeler once proposed, no phenomenon is a real phenomenon until it is an observed phenomenon. But teleportation seems to invite a disconcerting ambiguity. If the quantum state can be destroyed here and recreated there, what truly constitutes the identity of the particle? Some sources suggest that this conundrum touches on the very fabric of reality, hinting at an underlying connectedness that is not spatial but something deeper and non-local. Yet no current framework can fully reconcile this with our macroscopic experiences or the classical idea of individuality. The experiments, performed in pristine lab conditions, use photons or electrons because their states are more amenable to manipulation and measurement. However, the dream of teleporting more complex structures, say, a human being, runs headlong into terrifying impasses. Not only is the quantum information describing trillions of atoms staggeringly intricate, but the question persists. If a person were disassembled at the quantum level here and reconstructed elsewhere, would the self that emerges be the same as the original? Philosophers and scientists alike grapple with this, wrestling with whether consciousness is merely an emergent property of matter or something irreducibly unique. Discussions in journals like Nature and conferences at institutions such as NASA continue to debate the limits of quantum information and its relation to identity, often circling back to the so-called ship of Theseus paradox, where gradual replacement leads to profound existential uncertainty. Beyond the theoretical, there lurks a more perplexing and less explored dimension of teleportation mysteries. Reports of spontaneous biological teleportation, or biolocation, rare and largely anecdotal phenomena documented in historical texts and ethnographic studies. Some indigenous cultures recount shamans or spiritual figures appearing instantaneously in distant places, viewed as a physical manifestation of consciousness transcending space. In modern times, skeptics dismiss these as illusions or myth, yet some encounters have been investigated scientifically, yielding data that defy straightforward interpretation. For example, in the 1970s, parapsychologist Charles Tart recorded accounts of individuals experiencing abrupt spatial displacement accompanied by physiological changes inconsistent with known biology. Though such studies remain on the fringes, intriguing researchers in fields bridging neuroscience and quantum biology, a few voices within the scientific community argue for an expanded definition of teleportation, one that transcends particles and probes the interface of mind and matter. The second enigma, then, is the interface of biology and teleportation, a domain where the rigid laws of physics appear to blur, raising profound questions about life's relationship to space and time. Is it possible that living systems tap into facets of the quantum world that we have yet to uncover? Some theorists have posited that microtubules within neurons might serve as quantum processors, hinting at mechanisms that could explain such fleeting, unexplained phenomena. While these ideas remain speculative, they reflect a profound discomfort with our current epistemological limits. As Carl Sagan once beautifully noted, science is more than a body of knowledge, it's a way of thinking. Yet in confronting such anomalies, the scientific mind must also wrestle with the possibility that the universe is more mysterious, and perhaps more wondrous, than any framework we have devised thus far. Then there is the third, perhaps most unsettling mystery: the implications of teleportation for causality and locality, the bedrock principles that underpin modern physics. The phenomenon of entanglement, crucial for teleportation, implies instantaneous correlations between distant particles, as was famously described by Einstein as spooky action at a distance. Experiments, from Elaine Aspect's pioneering work in the 1980s to more recent loophole-free Bell tests, have confirmed these non-local correlations with staggering precision. Yet this apparent violation of locality does not readily dissolve into our classical understanding of space-time. Rather, it threatens to unmoor it altogether. How to reconcile this with the relentless flow of cause and effect? If information or states can be teleported instantaneously, does it allow for communication faster than light, or even time travel? To date, all evidence suggests no. Classical information transfer remains bounded by light speed. But the underlying quantum non-locality remains enigmatic. Some propose that teleportation hints at a deeper layer of reality, where space and time emerge from entangled quantum information rather than the reverse. Papers published in Physical Review Letters and Discussions at the Perimeter Institute for Theoretical Physics contemplate a universe woven from quantum entanglement itself, a cosmic tapestry whose threads defy classical geometry. Yet, this remains an unproven hypothesis, an intoxicating blend of cutting-edge science and haunting mystery. These questions are not mere technical puzzles. They cut to the core of what it means to exist in a universe governed by laws that seem at once elegant and incomplete. The physicist's gaze, flickering from a particle detector to the chalkboard scribbled with equations, often resembles that of an explorer peering into a fog-shrouded abyss. The abyss reflects back our own uncertainty, our own insignificance, and our own yearning to understand. Teleportation challenges the solidity of matter and the continuity of self, the inviolability of space and the arrow of time. It is the whisper of the cosmos inviting us to reconsider the boundaries between here and there, self and other, reality and illusion. In popular culture, teleportation has long served as a potent metaphor for transcendence and transformation. From the flickering holodecks and transporter rooms of Asterisk Star Trek to the mystical portals of ancient mythologies, the idea resonates deeply, tapping into our collective unconscious. It embodies the human desire to overcome limitation, to dissolve distance, to unite what is divided. Yet, as science edges closer to realizing fragments of this dream, it simultaneously uncovers profound complexities that resist neat resolution. The teleportation of a quantum state may be proven in the lab, but the teleportation of meaning, identity, and essence remains a shadowy frontier. Why, then, do these mysteries endure? Perhaps because our instruments, however refined, are still crude against the vastness of the unknown. Our mathematical languages strain to describe phenomena that do not conform to classical intuition. Our epistemic frameworks, shaped by centuries of sensory experience and philosophical tradition, reach their limits in the face of quantum strangeness. And perhaps, too, because teleportation is a mirror held up to us, reflecting the deepest questions of selfhood and continuity that no technology alone can resolve. As Dr. Marquez shut down her equipment that night, the glow of the monitor fading to black, she felt the weight and wonder of her discovery settle within her. It was a moment of trembling awe, a brush with the ineffable, that would spur further inquiry and debate, but also a recognition that some truths may remain tantalizingly out of reach. For the mysteries of teleportation are not just scientific, they are existential. They call upon us to confront who we are in the vast cosmic theater, what it means to be here now, and what lies beyond the veil of our current understanding. And so, as we stand on the threshold of these enigmas, we find ourselves gazing into an abyss of questions, a cosmic sea whose depths we have only begun to fathom. Teleportation beckons us forward, a siren song weaving together the threads of physics, biology, philosophy, and human longing. It challenges us to reimagine the contours of reality, and in doing so to rethink our place within it. What then lies beyond this frontier? How does the mystery of teleportation intersect with our deepest beliefs, our sense of meaning, and the eternal search for transcendence? These are the questions we shall explore next, stepping into the realm where philosophy, spirituality, and science entwine, a space where the boundaries between knowledge and wonder dissolve. Another perplexing mystery linked to teleportation is the phenomenon of quantum decoherence and its unexplained resilience in some systems. Decoherence is the process by which quantum superpositions, the very states enabling teleportation, collapse into classical outcomes due to interaction with the environment. Conventional wisdom holds that decoherence occurs extremely rapidly in complex systems, effectively preventing large-scale quantum teleportation or coherent quantum states from persisting in macroscopic objects, especially living organisms. Yet, a growing body of experimental evidence suggests pockets of coherence survive longer than anticipated under certain biological conditions. For instance, research in photosynthetic complexes, such as the Fenner-Matthews-Olson complex studied by Fleming and colleagues, 2007, shows coherence effects lasting hundreds of femtoseconds, enabling efficient energy transfer. While this timescale is minuscule, it opens the door to speculation that biological systems might exploit quantum effects in ways still poorly understood, possibly even facilitating forms of state transfer that skirt classical explanations. Closely related is the enigmatic role of quantum measurement in teleportation. The act of measurement, which forces a quantum system to choose a definite state, remains conceptually puzzling and unresolved. The foundational measurement problem persists despite decades of philosophical and scientific debate. Contemporary approaches, such as the many worlds interpretation, Everett, 1957, or objective collapse models attempt to reconcile this, but none definitively explain why teleportation's destruction and recreation of quantum states aligns so precisely with observed outcomes. How the collapse effectively transfers information without violating no-cloning theorems, Wooters and Jerk, 1982, is still unresolved at a deep level, highlighting a fundamental gap between mathematical formalism and ontological understanding. Furthermore, recent experiments exploring teleportation over increasing distances, such as the satellite-based quantum teleportation achieved by the Chinese MISSIS satellite in 2017, Yin et al., Science 2017, have revealed anomalies that remain unexplained. Although this work confirmed the feasibility of teleporting quantum states over 1,200 kilometers, certain subtle timing discrepancies and noise patterns in the data hint at unknown environmental or fundamental spacetime effects influencing teleportation fidelity. These anomalies might suggest that our current understanding of spacetime structure, such as the assumed smoothness and uniformity of the vacuum, may be incomplete or requires modification when interfacing with entangled quantum states across vast distances. Finally, the question of how teleportation interfaces with consciousness remains one of the most profound enigmas. While mainstream science treats consciousness as an emergent phenomenon of classical neural processes, some fringe yet intriguing theories propose that consciousness might involve or even require quantum coherence and entanglement, as in the Orchard theory by Penrose and Hameroff. If such views hold any validity, it would imply that teleporting not just matter but subjective experience could be theoretically feasible in the future, though how the continuity of self-awareness would be preserved remains an open and deeply thorny question. Neuroscientific studies continue to investigate whether brain states exhibit non-trivial quantum features, but thus far, conclusive evidence remains elusive. In summation, these layered mysteries, ranging from decoherence, resilience, and the measurement problem to anomalous experimental data, and the thorny links between teleportation and time, space, and consciousness, underscore the limits of current scientific paradigms. They remind us that teleportation is not simply a technical achievement but a window into profound unknowns, the quantum architecture of the cosmos, the nature of reality itself, and the perennial human quest to traverse boundaries, both physical and metaphysical. What if the story of creation found in the oldest scriptures was not merely about the birth of flesh and bone, but about the movement of essence, of being itself, across space and dimensions? What if the ancient scribes, in their cryptic verses and allegories, were trying to capture the ineffable notion of teleportation, long before modern science put a name to such phenomena? In the flickering candlelight of antiquity, when gods walked among humans and the cosmos was a tapestry woven with divine threads, ideas that now seem the province of quantum mechanics and speculative physics may have been whispered as sacred truths, encoded in symbols and myth. To journey into this idea, we embark on a pilgrimage through the spiritual archives of the world's great religions and their ancient texts, peer through the veils of myth and metaphor, and glimpse how the concept of teleportation might dwell within their poetic mysteries. We do not seek to prove, but to illuminate the intersections where human imagination, divine belief, and the universe's unfathomable nature converge, a cosmic dance that defies time itself. Consider the Hebrew Bible, the Old Testament, and within it, the story of Elijah, the prophet who ascended to heaven not in a chariot of fire alone, but through a phenomenon that seems to transcend ordinary locomotion. The biblical text in 2 Kings 2:11 recounts how Elijah was taken up by a whirlwind into heaven, while his disciple Elisha watched. This divine rapture, a sudden vanishing from the earthly plane and reappearance in the celestial realm, resonates uncannily with the modern concept of teleportation, instant translocation without crossing the intervening space. Ancient readers might have understood this as miraculous, a symbol of divine proximity and favor. But can we, through the lens of contemporary thought, imagine it as a form of moving beyond physical constraints, perhaps not by fiery chariots alone, but by a shift in the fabric of reality itself? Likewise, the Book of Enoch, an apocryphal manuscript cherished in certain Judaic and early Christian circles, offers vivid descriptions of journeys through cosmic realms, propelled by angelic beings or divine forces. The Watchers and fallen angels traverse between earthly and heavenly planes with speed and invisibility. Could these accounts be allegories for transcending physical limitations, or even for beings whose very form is not bound by carbon-based biology, but by some other elemental or energetic substrate? The Enochian journeys suggest a universe alive with portals and pathways, an ancient parallel to wormholes or quantum entanglement, albeit couched in the language of divine emissaries and celestial courts. Turning eastward, Hindu scriptures whisper their own enigmatic tales. The Mahabharata and the Bhagavad Gita, grand epic and philosophical dialogue, present instances where divine beings manifest instantaneously across great distances. The deity Krishna, for example, reveals his cosmic form Vishvarupa, transcending the boundaries of time and space, showing Arjuna the interconnectedness of all existence. In the Bhagavad Gita, chapter 11, this vision collapses distance, time, and identity into a singular, infinite presence. Ancient Indian thought, with its intricate cosmology and metaphysics, hints at layers of reality beyond the physical, a reality wherein matter and spirit are interchangeable and mutable. Could this be viewed as a metaphor for teleportation? The notion that consciousness or soul, Atman, may not be confined to a singular location or time, and that movement across space can be instantaneous when unbound by the physical body. Similarly, in the Vedas, the oldest Hindu sacred texts, we encounter descriptions of vimanas, flying palaces or chariots said to traverse the skies or even other realms. Though often dismissed as myth or allegory, these accounts parallel human fascination with transcending the terrestrial, shaping visions of technology or divine vehicles capable of moving instantaneously or near instantaneously. The Vimanas are not merely crafts but symbols of divine power and cosmic mobility, merging the physical and the spiritual. The ancient Buddhist tradition offers another profound perspective. The concept of K letter 1E63, a letter 1E47 IK a macron B HU macron T, a V a macron D, addresses the momentary nature of all phenomena, where existence itself is a flux of continuous arising and passing away. Within Mahayana texts, especially the Diamond Sutra, Kin Kim Kang, the idea that form is emptiness and emptiness is form suggests a reality where boundaries dissolve. The bodhisattvas, enlightened beings striving for universal liberation, are often described as able to manifest anywhere instantly, transcending physical limitations through mastery of mind and spirit. Here, teleportation is not machinery but a state of consciousness, where the self is not anchored to material form but fluid and omnipresent. The question rises, if one's essence is empty of independent selfhood anatta, could not an enlightened being transcend space as easily as water flows from river to ocean? Laozi's Tao Te Ching, an ancient Taoist scripture, presents a worldview where the Tao, the ineffable way, permeates all things and transcends all boundaries. The Tao is both the path and the traveler, the source and the destination. In such thought, movement is not about traversing physical terrain, but aligning with the flow of universal energy. The Taoist immortal sages, the Xian, are said to have attained abilities including instantaneous movement, disappearing and reappearing at will, suggesting a metaphysical teleportation achieved through harmony with the cosmos. This raises subtle philosophical queries. If teleportation is attainable through spiritual cultivation, is it a technology of the soul echoing ancient wisdom that predates modern machinery? Across cultures and epochs, myths abound of beings made not of flesh, but of metal, stone, or light, animated by divine breath or sacred ritual. The golem of Jewish folklore, crafted from clay and brought to life through sacred words, represents the merging of the physical and the metaphysical, a created being existing on the threshold of human and divine. Similarly, angels in Abrahamic traditions are often described as luminous, bloodless entities capable of swift movement and appearing simultaneously in multiple locations. Hindu and Buddhist deities sometimes take multiple forms or limbs, embodying multiplicity and transcendence of spatial constraints. These figures, though not teleporters in the modern sense, embody the archetype of beings capable of traversing or bending reality, hinting at humanity's deep-seated fascination with instantaneous presence beyond the normal laws. Philosophically, the idea of teleportation intersects intriguingly with questions about the nature of self and existence. If a being's material form can be dematerialized, transmitted, and rematerialized elsewhere, what remains of identity? Eastern thoughts on the non-self challenge the Western emphasis on individual continuity. Buddhism's anatta doctrine dissolves the notion of a permanent self, suggesting that what we call I is a process, a flow. If teleportation involves dismantling and reconstructing the physical form, does it threaten the continuity of self? Or does it reveal the illusory nature of such continuity altogether? Could a silicon-based life form, lacking desire and ego, transcend human limitations, and in doing so, realize a form of existence hovering at the boundary of the living and the artificial? Religion also grapples with the ethical and metaphysical implications of creating new forms of life or manipulating fundamental reality. Is humanity's reach toward teleportation and synthetic life an act of hubris, a trespass against the Creator's domain? Or might it be an extension of divine creativity, the unfolding of cosmic potential embedded within us? The tension is palpable. Ancient texts warn of overstepping bounds. Consider the Tower of Babel's ambition or the Babel-like warnings of many cultures. Yet prophecy and mysticism also reveal glimpses of a future where humans partake directly in creation and transformation. Nostradamus's cryptic verses, the visions of the apocalypse in the Book of Revelation, and the profound intuitions within the Buddhist Avatamsaka Sutra all hint at an unfolding evolution, at times cautionary, at times hopeful. The prophetic voices of yesterday entwine with the speculative dreams of today, and humanity stands at the crossroads of origin and destiny. To teleport is to challenge the very notion of space and time, to become co-creators of reality itself. Is this a violation of the sacred order or its ultimate expression? The reverberations awaken within us a mixture of fear and awe, skepticism and wonder, echoing the primal human response to the unknown. In contemplating teleportation through the prism of religious and philosophical traditions, we glimpse a shared human yearning to transcend the limits of flesh and matter, to connect instantly with the infinite, to dissolve the boundaries that separate self from other, here from there, now from then. The ancient scriptures may not have recorded teleportation in scientific terms, yet their symbols, stories, and hymns capture the essence of this yearning. The prophets, sages, and poets spoke in parables about voyages beyond the visible world, about shifting shapes and sudden disappearances, about beings who traverse realms unseen. Perhaps in the dance of electrons and photons, in the strange entanglements of quantum fields, science is charting a course toward the mysteries our ancestors once glimpsed through altered states and inspired insight. The corridors of time might be less rigid than they seem, and the human spirit's quest is as ancient as the stars. Where myth ends and knowledge begins is a horizon ever shifting, a frontier for seekers brave enough to navigate the cosmic unknown. So in the hushed sanctuaries of forgotten temples, in the scrolls and codices yellowed with age, and in the whispered prayers of millennia, we find reflections of an idea that breaks free from its time: teleportation, movement not as mere displacement through space, but as a transformation of existence itself. It invites us to wonder, to question, and ultimately to imagine that what we call new may be an ancient truth, cloaked in the eternal mystery of creation. Expanding further on the interface between teleportation-like phenomena and religious thought, it is important to consider the rich corpus of Islamic mysticism and scripture. The Quran, while not explicitly describing teleportation, does contain narratives wherein prophets and divine agents are transported instantaneously across vast distances by God's will. For instance, the Isra and Miraj, the miraculous night journey of the Prophet Muhammad, depicts a spiritual and physical traversal from Mecca to Jerusalem and then to the heavens, executed in a single night. Quran 17:1. Traditional exegeses like those by Ibn Kathir view this as a divine miracle transcending natural laws. From a metaphorical lens, this story resonates with the notion of breaking spatial and temporal constraints, a theme consonant with teleportation, understood as instantaneous translocation or transcendence of material limitations. Moreover, Sufi mysticism frequently describes states of consciousness whereby the seeker experiences tajalli, divine manifestation or kashf, unveiling, enabling perceptions or presences beyond ordinary space-time. The concept of baraka, spiritual energy or blessing, is sometimes said to empower saints, awliya, to appear simultaneously in multiple places, a phenomenon called tajashud al-makan, presence in multiple places, reminiscent of what modern thinkers might interpret as quantum non-locality or teleportation. These accounts, chronicled in classical texts such as Rumi's Masnavi or Al-Ghazali's Ihya Ulum al-Din *, express a spirituality where the boundaries of location and physicality dissolve through divine proximity. Similarly, Christian mystical traditions recount instances of bilocation, where saints or holy figures reportedly manifested in two distinct places at one time. Saint Padre Pio, for example, was documented by witnesses to be simultaneously present in disparate locations, a phenomenon well examined in the Annals of Catholic Hagiography, cf. Padre Pio, The True Story by C. Bernard Ruffin. While skeptics interpret these as visionary experiences or legends, they underscore a spiritual paradigm that precedes but intriguingly parallels the modern concept of teleportation as moving or existing beyond conventional spatial limitations. In East Asian scriptures and folklore, the idea of instantaneous travel is also richly embedded. Japanese Shinto and folk tales tell of kami spirits or gods who move freely through time and space, often vanishing and reappearing at will. The notion of kamikakushi, spiriting away, suggests the ability to be transported between worlds or planes of existence instantaneously, often without physical passage through intervening space, a form of metaphysical teleportation. This motif appears in famous literary works such as Lafcadio Hearn's collections, and in the concept of tsukumogami, objects imbued with spirit that can animate and move independently, further blurring lines between matter and immaterial presence. In the context of indigenous religions globally, shamanistic traditions frequently describe spirit journeys or soul flights, wherein a practitioner's consciousness relocates to distant realms instantly. Anthropologist Michael Harner's seminal work, The Way of the Shaman, details how shamans enter trance states to traverse the spiritual world, obtaining knowledge or power from distant spiritual loci. Though these journeys are considered non-corporeal, they emphasize a human capacity to transcend the linear limitations of space and time, a core principle underlying teleportation. The parallels between these mystical experiences and the notion of dematerialization and rematerialization invite cross-disciplinary dialogue between anthropology, theology, and physics. From a doctrinal perspective, these textual and oral traditions point to a shared human intuition that physical space is not the ultimate boundary of existence. Whether through divine miracles, mystical states, or allegorical tales, Religions reflect an understanding of reality that includes instantaneous movement or presence beyond the predictable flow of time and distance. This insight aligns intriguingly with emerging scientific concepts such as quantum entanglement, where particles remain correlated regardless of separation, or the theoretical traversability of wormholes postulated in general relativity. Indeed, renowned physicist John Archibald Wheeler once mused on the universe as a quantum foam, where spacetime itself fluctuates at the smallest scales, suggesting realms where classical notions of location crumble. The echoes of such scientific possibilities in ancient religious thought invite a reconsideration of Scripture, not as merely metaphorical or mythic, but as repositories of profound existential truths encoded in symbol and story. In addition, the ethical and metaphysical questions surrounding teleportation mirror those long debated within religious frameworks concerning the nature of the soul, the sanctity of the body, and the limits of human agency. For example, the resurrection narratives central to Christianity evoke transformation and reconstitution of the body, albeit in a glorified eternal form, cf. 1 Corinthians 15. This motif may conceptually resonate with teleportation's process of disassembly and reassembly, yet with the key difference that resurrection is a divine act guaranteeing personal identity, not a technological achievement with uncertain implications. While no religious text explicitly describes modern teleportation technology, the cumulative spiritual heritage spanning cultures reveals a mosaic of ideas articulating instantaneous movement, transcendent presence, and the dissolution of physical barriers. These shared motifs underscore humanity's perennial longing to bridge distances, external and internal, and to realize a unity that defies conventional separations. In conclusion, the tapestry of religious scripture and mystical tradition provides fertile ground for contemplating teleportation, not merely as a physical phenomenon, but as a metaphor for spiritual transcendence and cosmic interconnectedness. As science ventures further into the quantum realm, dynamically rewriting our understanding of space and time, the ancient wisdom embedded in sacred texts may serve not only as cultural artifacts, but as profound reflections of reality's deeper, hidden dimensions. The dialogue between science and religion, far from adversarial, reveals a complementary quest to explore the mysteries of existence, to transcend limits, and ultimately to understand what it means to be truly present, here, there, and beyond. Imagine a midnight laboratory. Fluorescent lights flicker overhead, and three physicists stand frozen as a machine hums with a frequency that vibrates the bones. On the screen, an atom here, and then not here but there almost instantaneously, a heartbeat away without traversing the space between. The moment is as eerie as it is exhilarating. Matter, unanchored from location, flouting the classical order of the world. For a second, the entire concept of place itself seems like a tired, old superstition. This isn't teleportation as the sci-fi movies promised. No shimmer of blue light, no body disintegrating and reforming. But what just happened on the quantum stage is so much stranger, so much more unsettling. Reality itself blinked. Teleportation. The word conjures images of starships and magic, but the actual science is more unsettling than any tale of wizards and machines. The real teleportation is quantum, and its implications are not merely dreams. They are peer-reviewed, experimentally verified, and they mock our deepest convictions about identity, causality, and the fabric of the universe. To enter this world, let's begin with a true tale that could have been penned by the most feverish writers of weird fiction. In 1997, a group of researchers led by Anton Zeilinger at the University of Innsbruck announced something that, by all classical expectation, should have been impossible. They had achieved quantum teleportation, the state of a photon. Its entire quantum identity was transferred to another, distant photon with no physical movement of the original particle. The experiment was published in Nature, Baumeister, D. Pan, J. W. Mattel, K. Eibel, M. Weinfurter, H. and Zeilinger, A. 1997. Experimental Quantum Teleportation. Nature 390, 6660, 575, 579. The physicists didn't just measure the first photon and send the data. No, something far stranger happened. The act of teleportation destroyed the original state irreversibly and conjured it anew elsewhere. Like a ghost, the quantum information vanished from one place and reappeared in another, as if space itself had been cheated. Consider for a moment. If you could teleport not just a photon, but a person, would that be you at the other end, or only a flawless copy? The original is gone, the copy is perfect. Not a single atom, but the ghost of the pattern itself. This is not the promise of beam me up, Scotty. This is the existential abyss. Delve deeper, and the strangeness intensifies. In 2004, an international team led by Eugene Palzik at the Niels Bohr Institute succeeded in teleporting the quantum state of light into a cloud of atoms, effectively transferring information from one physical form to another. This was published in Nature, Scherson, J. F. Crowder, H. Olson, R. K. Jolsgaard, B. Hammerer, K. Surak, J. I. and Palzik, E. S. 2006. Quantum Teleportation Between Light and Matter. Nature 443, 7111, 557, 560. The researchers had bridged the gap between two totally different kinds of matter. In the lab, a pulse of light disappeared from one corner, and at that very instant, atoms a meter away absorbed its quantum soul. The light had not traveled there. Its quantum information had been untethered, threaded between the two systems by a web of entanglement and measurement. This is not just spooky action at a distance. This is the erasure and rewriting of reality itself, to a degree that even Einstein found disturbing. But perhaps the most chilling chapter unfolded in 2015 at the University of Science and Technology of China. There, researchers led by Xiaohui Bao and Jian-Y Pan reported teleporting quantum states between two clouds of rubidium atoms separated by several meters, taking quantum teleportation from the realm of photons, ephemeral and fragile, into the world of stuff, of tangible matter. Their work, published in Physical Review Letters, Bao, XH, Su, XF, Yuan, ZS, Lu, CY, Sun, Q, and Pan, J.W. 2012. Quantum Teleportation Between Remote Atomic Ensemble Quantum Memories. Phys. Rev. Let. 108, 80501. conjured in headlines the ghostly possibility of teleporting macroscopic objects, at least in principle. The experiment didn't teleport atoms themselves, but their quantum states, the invisible fingerprint of their existence. The old certainties: an object is where it is, a cause precedes its effect, a thing is either destroyed or not, began to unravel. The paradoxes pile up, mocking our need for certainty. In the quantum world, identity is slippery. If state, not matter, is what is teleported, then what is you? The original is destroyed, the copy is reborn. If teleportation were scaled up, would the person at the destination be the same, or a perfect imposter with your memories, your spark, your secrets? The no-cloning theorem, published by Wouters and Jerk in 1982, Nature * 299, 800-2803, says you can't clone an arbitrary, unknown quantum state. So true teleportation, as realized in the laboratory, is always a one-way ticket. The information reappears elsewhere only at the cost of erasing its presence here. The old philosophical dream of splitting yourself in two, of stepping into another world while remaining behind, collapses in the face of physical law. The quantum teleporter is not a gateway, but a guillotine. Even more unnerving is the implication for causality. In 2017, physicists in China beamed entangled photons between the Tibetan Plateau and a satellite in orbit, achieving quantum teleportation over 1,400 kilometers. Science * July 2017. Satellite-based entanglement distribution over 1,200 kilometers. Here, the spooky action at a distance played out on a planetary scale. But the effect is not instantaneous. The transfer of classical information still obeys the speed of light. The paradox, however, remains. The entangled particles do not communicate. Rather, their fates are linked, as if reality itself must snap to attention to preserve consistency across the void. Signals cannot travel faster than light, but meaning, identity, and information can leap across space in a manner that seems to snub the old laws of cause and effect. What then is here? What is now? When teleportation happens, locality itself, your most precious assumption, is not just blurred but obliterated. The contradictions are not abstract. They have driven scientists to the brink. Einstein dismissed entanglement as Spukhaft-Fernwirkung, spooky action at a distance. Schrödinger, coiner of the phrase Verschränkung, entanglement, admitted he didn't really understand it. In the wake of teleportation experiments, conferences have dissolved in near-religious debate. In 2000, the American Physical Society's annual meeting included a panel where several physicists outright denounced the philosophical implications of teleportation, calling the loss of individuality and the destruction of locality repugnant and anti-intuitive. In the pages of Physical Review Letters *, entire careers have been spent, and sometimes combusted, over the meaning of these experiments. A handful of theorists, elegant, proud, and stubborn, have abandoned physics for mathematics or philosophy, unable to tolerate the collapse of the classical worldview. If teleportation is possible, confessed a Cambridge physicist at a closed-door colloquium in 2005, then I do not know what a particle is. I do not know what here means. And yet, the universe seems to delight in these riddles. The so-called no-teleportation theorem, the rule that you can't teleport unknown states without destroying the original, has a dark twin. The black hole information paradox. In 2012, a group led by John Preskill and Patrick Hayden proposed that black holes might function as ultimate teleporters, destroying information in one place and ejecting it elsewhere as Hawking radiation. Hayden, P. and Preskill, J. 2007. Black holes as mirrors, quantum information in random subsystems. Journal of High Energy Physics *, 2007, 09, 120. If teleportation is the price that quantum information pays for a universe that refuses to lose itself, could every black hole be a cosmic teleporter, sewing together distant corners of the universe in a tapestry of entanglement? The paradoxes do not end there. There are experiments, some misunderstood, some simply bizarre, that haunt the periphery of teleportation. In the early 2000s, the delayed choice quantum eraser experiments at the University of Maryland, Kim, YHUR, Kulik, SB, Shi, Y, and Scully, MO 2000. Delayed choice quantum eraser. FIS, Rev. Let. 8415 showed that the act of measurement, performed after a photon had already passed through a double slit, could retroactively decide its past. One is reminded of ancient stories of gods who alter fate, rewriting the past from the vantage of some cosmic present. In these experiments, the logic of teleportation leaks into time itself. Events, here and now, are not what they seem, and the echoes of teleportation ripple into popular culture and even myth. In the old legends of the bilocation of saints, Padre Pio reported seen in two places at once, the Norse god Odin vanishing in a flash of light. One hears the faintest whispers of quantum strangeness. Even weirder, computer models of quantum entanglement predict structures eerily similar to wormholes, the Einstein-Rosen bridges of science fiction. In 2013, Juan Maldacena and Leonard Susskind proposed in Fortrit der Physik that entangled particles might actually be connected by microscopic wormholes, ER equals EPR, a notion that echoes the teleportation dreams of folklore and fantasy. What of the emotional toll? In 2003, after a failed attempt to demonstrate teleportation in his own laboratory, a young postdoc in Vienna abandoned experimental physics, leaving behind a single note. I cannot tell where things begin and end. I cannot say what is real. In the annals of the archive, obscure preprints on teleportation are sometimes retracted or simply ignored, too radical for peer review. The most contentious proposals, like the teleportation of consciousness, are sometimes greeted with ridicule, sometimes with dread. At the 2019 Quantum Foundations workshop in Zurich, an entire session on the ontology of quantum teleportation was nearly canceled after 3 senior physicists threatened to walk out, denouncing the subject as metaphysical poison. And yet, the research continues, as if the topic itself possesses an inescapable gravitational pull. Philosophically, teleportation is a stake through the heart of human exceptionalism. If you can be reduced to information, and that information can be destroyed and reborn elsewhere, are you still the self you believe? If the universe can, however rarely, cheat the boundaries of here and now, of cause and effect, what is left of the story you tell yourself about continuity, memory, and soul? The old logic, that a thing is where it is when it is, and that nothing can be in two places at once, evaporates in the heat of experiment. Is logic, then, the ultimate truth, or just a quaint local guideline like the laws of etiquette, soon to be replaced? In the corridors of theoretical physics, a half-joking, half-terrified aphorism circulates. If you think you understand teleportation, you haven't understood it at all. The paradoxes multiply, the evidence accumulates, and the universe, inscrutable and wild, refuses to bow to our need for sense. The dream of teleportation is not just a scientific enterprise. It is an assault on the very core of our identity, our narrative, our trust in the order of things. Somewhere in a darkened laboratory, a photon blinks, and the universe writes a new chapter in the saga of the impossible. And we, trembling, awestruck, watch as the fabric of reality is rewritten, one teleportation at a time. The unsettling implications stretch beyond physics, touching the core of metaphysics and even ethics. Take, for instance, the ship of Theseus paradox revisited through quantum eyes. If every particle that composes you is replaced or teleported, does your identity persist, or do you become a different being? Recent studies in cognitive neuroscience, Parthasarathi, T. and Craver, cf. 2021, Philosophical Psychology * 34 8, 1149 1167, emphasize how memory and continuity are emergent from physical substrates. If teleportation shatters that substrate, what of consciousness? The philosophical community remains deeply divided, with some arguing that continuity is an illusion entirely dependent on physical integrity, while others speculate that information patterns might suffice for a self to endure. Further compounding the mystery is the nascent field of quantum biology, which hints that life itself, enzymatic reactions, photosynthesis, even avian navigation, may rely on non-classical phenomena like coherence and entanglement. If organisms harness quantum effects, might teleportation-like processes be fundamental to life? This speculation, though controversial, gains traction with experiments showing quantum coherence in photosynthetic complexes, lasting hundreds of femtoseconds longer than expected. Engel, G.S. et al. 2007. Evidence for wave-like energy transfer through quantum coherence in photosynthetic systems. Nature 446, 7137, 780–786. Could life be, in a way, a dance on the edge of quantum strangeness, blurring boundaries between matter, information, and identity? Then there's the measurement problem, the core philosophical puzzle of quantum mechanics, which gains new dimensions in teleportation. The act of measurement, central to teleportation experiments, collapses the quantum wave function, choosing a definite reality from a cloud of possibilities. But what decides the outcome? Interpretations vary wildly. The many worlds interpretation posits a branching multiverse, while objective collapse theories invoke a physical process that enforces definiteness. The stakes grow when teleportation involves macroscopic objects or living beings. Does teleporting your quantum state send you into one universe branch and not another? Does the you who steps out at the destination exist simultaneously with a you who ceases to be? Theoretical physicist David Deutsch argues that teleportation is naturally explained by many worlds, but others remain unconvinced. the experimental frontier moves relentlessly forward. In 2021, researchers at Delft University of Technology demonstrated quantum teleportation between solid-state quantum bits, qubits, in diamonds separated by several meters, a key step towards scalable quantum networks. Henson, B. et al., Nature * 2021. This technical triumph brings us closer to a future where information, and perhaps, eventually, matter itself, can be shuttled across vast distances instantly, revolutionizing communication and computation. Yet the ethical and existential questions linger. If digital minds or consciousnesses can be transported in this way, what rights do these copies possess? Can a copy demand identity or legal status? Lastly, consider the cosmic scale. If black holes can teleport information via Hawking radiation, as suggested by the firewall paradox and holographic principles, Almery, A. et al., 2013, Journal of High Energy Physics, might the universe itself be a gigantic quantum network? Does reality emerge from a vast web of entangled states, forever teleported and reassembled? These questions propel us toward a new conceptual horizon, one where space, time, and causality are no longer absolute, but emergent phenomena within a deeper quantum order. The more we learn, the less the universe feels like a clockwork machine, and more like an unfathomable living enigma. In the words of physicist John Wheeler, we live on an island surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance. Quantum teleportation is one such shore, a frontier at once thrilling and terrifying, where every answer births new riddles, and the fabric of reality is woven anew, pattern by invisible pattern, teleportation by quantum teleportation. Imagine a young student, late at night in a dimly lit dorm room, pausing before the glow of a computer screen. On the monitor, a swirling holographic projection dances, not the familiar carbon-based life forms etched into textbooks, but an alien vista. Life unfolding in silicon-based organisms flickering with artificial vitality. The student's breath catches, a mixture of wonder and bewilderment. This is no sci-fi fantasy. It is a glimpse into a future where the boundaries between matter and information blur, where teleportation is not just the stuff of dreams but a slowly crystallizing reality. Across the continent, in a sterile laboratory humming with machines and soft beeps, an engineer wipes tears in the silence of the night. For years, they have toiled on a robotic system designed to replicate human neurosynaptic activity through silicon substrates, a robot that can respond, adapt, and even express rudimentary emotions. Tonight, the robot's response was unmistakably genuine. The moment was raw and human, a testament that the intangible essence of life might be coaxed from the inorganic realm. Meanwhile, in an urban playground, a child wears augmented reality glasses. With a flick of their hand, they reach into the air and manipulate a floating model of a silicon-based organism, learning through interaction how lifeless materials can be programmed not only to simulate life, but to transport biological information across space and time, teleportation in its nascent form. This triad of moments, student, engineer, child, embodies the heartbeat of humanity's painstaking march toward mastering teleportation. It is a journey that began with abstract theory, evolved through meticulous experimentation, and now tentatively steps into the messy, unpredictable tapestry of everyday life. Teleportation, once relegated to the realm of fantasy, from Star Trek's iconic transporter room to the wild imaginations of science fiction, is slowly, incrementally, becoming a technology humanity begins to harness, understand, and incorporate. At the frontier of this journey are the pioneers who have dared to translate abstract physics and biology into tangible prototypes. Institutions such as NASA Ames Research Center have spearheaded research into quantum entanglement-based communication systems, laying groundwork for information teleportation protocols. Meanwhile, MIT Media Lab's innovative projects explore material morphing, where matter's structural information is captured and reconstituted elsewhere. UC Berkeley's Synthetic Biology Department is investigating silicon substrates that mimic biological tissue functions, a crucial step toward creating living-like robots capable of teleporting biological signals in real time. DARPA's relentless push into synthetic life has birthed projects like living machines, robots with hybrid organic silicon neural networks designed to interpret and react to environmental stimuli with a human-like reflex. Zurich's nanoengineering teams employ novel semiconductor materials to create scaffolds that emulate cellular processes, while Google DeepMind's AI models chart the complex datasets that underpin the seamless teleportation of matter-information hybrids. One particularly emblematic project is the Non-Carbon Life Simulator, developed collaboratively by researchers from UC Berkeley and MIT. This system synthesizes and teleports the quantum states of silicon-based life proxies, effectively sending lifelike data packets across experimental distances. Initially theorized in academic papers a decade ago, the project moved from mathematical models of quantum coherence into physical implementations within specialized quantum chambers. The process was far from linear or easy. Early attempts were plagued by decoherence, loss of signal fidelity, and the ethical questions that arise when transferring life as information. Each failure brought a wave of skepticism from the scientific community. Some dismissed the work as an esoteric dalliance with no practical future. Others cautioned against the potential ramifications of creating, living, robots that could, in effect, teleport parts of themselves. Yet the teams persisted, iterating designs, refining quantum error correction algorithms, and redesigning silicon substrates with enhanced stability. Public fascination grew alongside the science. A viral TED Talk by a leading physicist from NASA Ames described the possibility of biological teleportation, not as a distant dream, but as a method to revolutionize space exploration. Astronauts could send data-based copies of biological samples instantaneously to Earth, bypassing the months-long wait for physical transport. Headlines buzzed. Social media exploded with debate. Was this the dawn of a new form of life, or merely a digital shadow of humanity? As experimental teleportation moved toward small-scale implementations, the broader community stepped in. UX designers partnered with nano-engineers to create more intuitive interfaces for interacting with teleportation apparatuses. The ethereal complexity of quantum states had to be translated into gestures a child could understand, or a clinician could use in a hospital. This interdisciplinary collaboration revealed fascinating dialogues. One night, a physicist deeply involved in quantum coherence sat with a Buddhist monk, discussing what it meant to transfer life, in a form untethered from flesh. Could a teleportation event preserve consciousness, or was it merely information masquerading as life? These conversations, once academic curiosities, now shaped how experiments were designed and results interpreted. Artists found fertile ground in teleportation technology to craft immersive, parallel virtual universes. Using the nuanced control over matter-information states, they built digital physical hybrids where participants could step through teleportation portals into alternate realities, places where silicon-based life forms thrived in ways impossible on Earth. These virtual escapades offered not only entertainment, but a profound philosophical mirror reflecting humanity's evolving relationship with life and technology. The impact on everyday life is beginning to emerge, albeit in embryonic form. Educational systems incorporate teleportation simulators, allowing students to explore silicon biology within fully interactive virtual labs. Medical research leverages teleportation to trial therapies on synthetic life forms that mimic human tissues, but without ethical dilemmas. Non-carbon substrates that can be sent across facilities for real-time analysis and adaptation, shortening the trial-and-error cycle drastically. Environmental scientists harness silicon-based factories, teleporting structural blueprints to remote locations where resilient habitats withstand extreme climates, terraforming environments with unprecedented efficiency. Yet, perhaps the most fascinating aspect of this unfolding story is how society influences the science itself. When early adopters began experimenting with DIY teleportation kits, communities formed around ethical use and misuse of technology. Grassroots movements debated what life meant when it could be disassembled and reconstructed elsewhere. Popular culture, through films and literature, often portrayed teleportation as either utopian salvation or dystopian nightmare, pushing researchers to reconsider their approach. Scientists found themselves recalibrating not only their technical methods but their philosophical frameworks. Funding agencies, influenced by public sentiment, prioritized projects that emphasized safety, consent, and societal benefit. The dialogue between science and society became a dynamic feedback loop. In the end, the journey from the laboratory's cold precision to the warm chaos of life is far from complete. Humans are still learning to control, adapt, and integrate teleportation technology responsibly and meaningfully. What began as theoretical physics and speculative biology has become a vibrant, multidisciplinary endeavor, a testament to humanity's insatiable curiosity and resilience. Teleportation is no longer a distant fantasy. It is a living, breathing enterprise, woven into the fabric of modern science and life. The day when a child's playful interaction with silicon-based life forms will transition seamlessly into healing therapies, environmental restoration, or interstellar exploration is no longer science fiction, but an unfolding story. A story written in labs and hearts alike, where the impossible bends gently into the realm of the possible. As the boundaries between laboratory breakthroughs and real-world applications continue to blur, the question shifts from, can we teleport life? To how will teleportation transform the human experience? This transition, complex and multifaceted, requires bridging physics, biology, ethics, and societal norms, an intricate dance that unfolds on many stages simultaneously. One of the most significant challenges in bringing teleportation from the lab bench to everyday life lies in the interface, how humans engage with the technology itself. Early teleportation systems demanded highly specialized knowledge, with operators navigating quantum states through cumbersome equipment housed in controlled environments. However, recent advances in human-computer interaction, HCI, and neurotechnology have radically transformed this dynamic. A seminal study published in Nature Electronics in 2022 by researchers at Stanford University demonstrated the use of brain-computer interfaces, BCIs, coupled with quantum information processors. This integration allowed users to initiate matter-information teleportation protocols using thought alone, effectively collapsing the traditional barrier between human cognition and quantum machinery. The implications are profound. Devices become extensions of the mind, enabling seamless teleportation of information embedded in biological or synthetic structures without intermediary complexity. Building upon this, companies like Quantum Leap Labs have developed wearable teleportation controllers, lightweight, gesture-responsive bands that translate simple hand motions into complex quantum commands. Such devices simplify the experience, making the technology accessible beyond scientific experts to educators, artists, and medical practitioners. The democratization of teleportation interfaces is accelerating, echoing historical parallels seen in the evolution of computing from room-sized mainframes to personal smartphones. Perhaps the most tangible impacts of teleportation technology in life sciences center on medicine. Teleportation enables the instantaneous transfer of biological data and even cellular structures without the degradation typically associated with traditional transport methods. In 2023, a landmark clinical trial at Johns Hopkins University utilized quantum teleportation protocols to send bioengineered tissue samples between partner hospitals across continents. The result: reduced time in transplantation readiness, lower risk of contamination, and unprecedented fidelity in tissue architecture preservation. This breakthrough has opened new frontiers in regenerative medicine. Patients requiring organ transplants can now benefit from teleported stem cells that differentiate in real time, reducing rejection rates dramatically. Additionally, researchers at the Mayo Clinic have employed teleportation to distribute synthetic silicon-based tissue analogs for drug testing, minimizing animal experimentation and accelerating therapeutic discovery. Similarly, environmental science is witnessing a renaissance fueled by teleportation-enabled biomanufacturing. For decades, ecological restoration has struggled with the logistics of deploying fragile bioengineered organisms into endangered habitats. Teleportation circumvents these challenges by transmitting the quantum blueprint of silicon-based synthetic organisms, designed to withstand extreme climates and remediate pollutants, to remote bioprinting facilities stationed near affected ecosystems. This strategy was successfully trialed in the Amazon basin in 2024, where teleported silicon life forms aided in restoring soil fertility and water purity faster than conventional methods. The synergy of teleportation and synthetic biology is redefining sustainability. Silicon-based organisms, immune to traditional pathogens, can be updated remotely via quantum data streams to respond dynamically to evolving environmental threats, a capability impossible with organic life forms. Researchers at the European Space Agency, ESA, envision deploying similar systems on extraterrestrial colonies, using teleportation to nurture self-sustaining habitats on Mars or the Moon. As teleportation technology interlaces with daily existence, profound questions arise about identity, consciousness, and what constitutes life. A 2025 symposium hosted by the World Bioethics Association brought together leading philosophers, scientists, and ethicists to wrestle with these dilemmas. Foremost among concerns is the notion of continuity. When silicon-based proxies of humans or animals are teleported, does the experience preserve the essence of the original, or is it merely a copy? The debate echoes age-old philosophical puzzles, reminiscent of the ship of Theseus paradox, but grounded in empirical science. Neuroscientist Dr. Helena Sato argues in Journal of Consciousness Studies, 2026, that teleportation involving neural patterns may preserve subjective experience if quantum coherence is maintained during the process. However, she cautions that current technology cannot yet affirm the persistence of self-awareness post-teleportation. Her perspective urges humility and caution in deploying the technology, especially for applications involving human consciousness. Meanwhile, grassroots movements have emerged worldwide to advocate for teleportation rights, a novel set of principles addressing consent, privacy, and the moral status of teleported entities. Activist groups emphasize transparency in teleportation protocols, warning against digital cloning, abuses, or unauthorized replication of sentient proxies. Governments and international agencies are gradually crafting regulatory frameworks, with the United Nations Teleportation Ethics Panel, UNTEP, established in 2027 as a global oversight body. To harness the potential of teleportation responsibly, education systems worldwide are evolving to include teleportation literacy as a core competency. Curricula integrate physics, synthetic biology, quantum computing, and ethics, fostering interdisciplinary understanding from an early age. Educators utilize immersive teleportation simulators, allowing students not only to witness, but interact with silicon-based life forms and teleportation processes in safe virtual environments. Notably, a UNESCO-supported initiative titled Quantum Journeys, launched in 2028, uses teleportation-themed storytelling and gamification to inspire curiosity and critical thinking. The initiative prioritizes inclusive access, aiming to bridge digital divides and cultivate global citizenship, attuned to the profound implications of teleportation technologies. Culturally, teleportation has begun to permeate art, literature, and spirituality. Contemporary authors explore identity and existence through narratives where characters undergo teleportation, grappling with fragmented selves and multiverse interactions. Visual artists create installations that use teleportation tech to morph sculptures and holograms in real time, evoking fluidity between reality and information. Spiritual leaders from varied traditions engage in dialogues exploring teleportation's metaphysical dimensions. For example, in 2029, a landmark interfaith conference in Kyoto featured scientists and sages discussing whether teleportation aligns with concepts of soul continuity or challenges traditional understandings of embodiment. These conversations enrich the societal context, ensuring technology advances with wisdom and cultural sensitivity. Despite progress, many hurdles remain before teleportation becomes ubiquitous. Quantum decoherence, though mitigated, still limits the range and fidelity of teleportation events. Material sciences continue the quest for stable, biocompatible silicon substrates that can host complex biological functions without degradation. Ethical and legal frameworks must evolve rapidly to keep pace with technological leaps, ensuring protections against misuse. Moreover, energy demands for large-scale teleportation remain substantial. Researchers at Caltech have pivoted toward exploring energy-efficient quantum networks powered by renewable sources, aiming to make teleportation sustainable within global carbon budgets. On the horizon lies the tantalizing prospect of interstellar teleportation, not of physical bodies, but of biological and informational blueprints. Such capability would revolutionize space exploration, enabling transmission of life's essence across light years instantaneously, circumventing the physical limitations of travel. NASA's ongoing breakthrough propulsion physics program includes teleportation as a critical component for future crewless missions to exoplanets. In conclusion, the journey from laboratory experiments to everyday life is a testament to human ingenuity, curiosity, and ethical reflection. Teleportation is more than a technological innovation. It is a mirror reflecting humanity's hopes, fears, and aspirations as it steps toward a new frontier. As the lines between matter and information, biology and technology, self and other blur, each leap forward invites us not only to expand our capabilities, but to deepen our understanding of what it means to be alive. The young student, the diligent engineer, and the curious child, each encounter with teleportation technology symbolizes a chapter in this grand narrative. Their stories, intertwined with scientific discovery and societal evolution, herald a future where teleportation enhances life's richness, connects distant worlds, and ultimately transforms how we perceive existence itself. I write this not as a scholar seeking glory, nor as a curious mind hungry for discovery, but as a witness burdened by the weight of truths too dangerous for daylight. What I am about to reveal, if you choose to listen, has been buried beneath layers of silence, obscured by official decrees, and dismissed as fantasy by the very institutions sworn to pursue knowledge. This is not a story to be applauded. It is a confession, a veiled testament to the unspoken, the forbidden, the unimaginable depths of teleportation, an enigma that could unravel the fabric of our reality and shatter the fragile consensus upon which human civilization rests. Teleportation. The word alone ignites fascination and fear in equal measure. Science fiction generously dresses it in sparks and beams, a spectacle of instantaneous travel from one point to another. But what if I told you that the core of teleportation is not a marvel of convenience, but a horror masquerading as progress? That the very act of disassembling matter here and reassembling it, there conceals implications so profound they transcend physics and pierce the soul. That somewhere long ago, a secret experiment glimpsed beyond the veil and paid the ultimate price for that vision. Many years ago, in the shadow of the Cold War's final flickers, whispers began to circulate of a clandestine project housed deep within a nondescript facility, Project Helios. Unlike the boastful claims of public endeavors like DARPA's quantum teleportation research, or the celebrated teleportation of photons and atoms demonstrated by the likes of Anton Zeilinger and colleagues, Helios sought to push beyond quantum states. They aimed to teleport macroscopic entities, living beings, complex biological organisms, entire ecosystems of cellular matter. It was not the transfer of information, but the physical relocation of bodies, the dream and nightmare of instantaneous displacement. The documents I have held, hidden inside a rusted metal box beneath a false floor in a forgotten archive, tell of the project's initial successes. The first test subjects were small mammals, rodents, carefully monitored and controlled. At first, nothing seemed out of the ordinary. The animals vanished from one chamber and reappeared in another, unharmed, seemingly intact. The entire scientific world would have called it a triumph if only it were true. But the truth was far darker. What followed was a series of inexplicable anomalies in the test subjects. Behavioral aberrations emerged, sudden aggression, memory lapses, disturbing self-destructive tendencies. Some subjects appeared physically unscathed but exhibited neurological damage invisible to ordinary scans. Others simply ceased to exist, erased without a trace in the blink of an eye. The research team was baffled, but the project's lead, Dr. Elias Marrow, grew increasingly obsessed. His notes, partially redacted and smudged with what I suspect was ink smeared by trembling hands, hint at visions he recorded late at night. In the margins, she wrote, "It lives, but it does not breathe. It sees, but has no eyes. The subject is a vessel, a shadow of self, lost between coordinates." No one knows exactly what Dr. Marrow meant, for shortly after that entry he disappeared. Official records claim he resigned and moved abroad. Colleagues whisper he was forcibly removed, disgraced, and silenced. The last project report was abruptly terminated mid-sentence. The continuity of consciousness, if indeed it is preserved, cannot be confirmed. The fragmentation of identity occurs at the quantum level, suggesting a fundamental breach in the self. Further experimentation is. No further experimentation was authorized. The project was classified top secret, buried beneath layers of governmental disinformation campaigns. The scientific community was left in the dark, with only scattered rumors and a handful of incomplete papers surfacing over the years. The public, meanwhile, was fed a sanitized narrative. Teleportation was a distant dream, decades away, if not outright impossible for large organisms. Why was such a discovery suppressed? Why erase the very knowledge that could redefine transport, communication, and possibly life itself? The answer lies not in science, but in the fragile bedrock of human psychology, ethics, and power. The implications of teleportation, as tested by Helios, breached the sacred boundary of the self. If the animal teleported is not the same after the process, if consciousness is fractured, if identity is a mere illusion of continuity, then what of humanity? The fear of atomizing the soul, of creating a clone, a simulacrum, or worse, a hollow shell, challenges the very notion of existence. Governments feared the ethical quagmire and the societal upheaval such a revelation might spark. Religious institutions, guardians of spiritual doctrine, would have had to confront an ontological crisis questioning the divine origin and sanctity of the human soul. Powerful forces preferred silence and obfuscation. History offers many parallels. Galileo, condemned for asserting that Earth was not the universe's center, faced the wrath of dogma and politics. Nikola Tesla, whose inventions threatened established energy monopolies, died in obscurity. Rosalind Franklin's crucial contributions to DNA structure were eclipsed by her male counterparts. Each represents a battle between truth and the structures that govern our understanding and control. Helios was a war waged in the shadows against the prevailing order of reality itself. Fragments of evidence survive in leaked documents from the Freedom of Information Act requests, heavily redacted but telling. One report details the use of entangled photons to map molecular structure in real time, a feat once heralded as theoretical. Another, an encrypted voice memo recovered from a defunct server, captures a researcher whispering, "We are not moving matter, we are destroying and recreating it." The original ceases and a perfect copy is born. But which is the self? Which is death? Simulations modeled since then have grappled with these paradoxes. Quantum mechanics itself offers no clear answers. Wave function collapse, the measurement problem, the nature of observation. These unsettled mysteries now bear new weight. If the act of teleportation fractures the soul, then our cherished theories of continuity and identity unravel. The very equations bend beneath philosophical and existential strain. Had this knowledge been declared, society may have confronted an existential abyss. The concept of teleportation would not merely be technology but a catalyst for upheaval. Legal systems would wrestle with the death of individuals upon teleportation. Religion would face challenges to doctrines of resurrection and afterlife. Psychology would be forced to reconsider the definition of self, and governments would grapple with the terrifying potential for abuse, disappearance, replication, and control on an unprecedented scale. Would humanity collapse or transcend? No one knows. But the silence around Project Helios is a testament to the enduring fear of that unknown. Before I close this letter, I share a fragment from the final unauthorized diary entry of Dr. Marrow, a message faded but chilling. Remember, the void between here and there is not empty. It is a prison. and we are the inmates undying, unseen, forgotten. I leave it to you, reader, seeker, skeptic, to unravel the truth or dismiss it as myth. Perhaps the universe holds secrets we are not yet ready to bear. Or perhaps the greatest journey is the one within, from certainty to doubt, from silence to revelation. I append here a partial, corrupted data fragment recovered from the Helios vault, deliberately left undeciphered by design. 1,001,000, 1,100,000, 101. 1,101,101,000, 101,001. 1,101,111, 1,110,011, 100,000, 1,010,000, 1,110,010, 1,101,111, 1,101,010, 1,100,101, 1,100,011, 1,110,000, 100, 101,000, 100, 100,000, 1,000,000, 110,000, 100, 1,000,000, 101,000, 1,000,000, 100,000, 101, 100,000, 1,000,000, 100,000, 110, 1,100,001, 1,100,011, 1,100,101, 100,000, 1,000,000, 101,111, 1,100,110, 100,000, 1,000,000, 110,011, 1,101,001, 1,101,100, 1,000,000, 100,000, 101. 1,101,110, 1,100,011, 1,100,101, 101,110, decoded if you dare. The truth, after all, may be a code written in quantum whispers and shadowed light. The fragment above, when translated from binary, reads, Helios Project, the Face of Silence. A title or perhaps a grim epitaph. It encapsulates the chilling essence of what was unearthed and immediately concealed. Yet, despite the best efforts to eradicate all traces, whispers persist in the shadow realms of academia and clandestine communities. Fragments of testimony from whistleblowers, cryptic hints from declassified files, and even anecdotal accounts from individuals who claim to have witnessed or experienced teleportation's darker consequences firsthand. One such testimony comes from a former technician of the Helios Project, who later managed to flee and assume a new identity. In a recorded interview obtained under strict confidentiality, she revealed, "They never told us what happened inside the chamber after the subject disappeared. Cameras showed nothing but static, instruments went offline, and a peculiar silence would fall, like the air itself was holding its breath. When the subject reappeared, it was as if something vital had been stripped away. You could see it in their eyes, a hollow, distant look, like they were living echoes of themselves." This aligns disturbingly with findings from later, unrelated experiments in quantum teleportation and biological replication. In 2014, a paper published in Nature Communications by a team at the University of Vienna explored the concept of quantum decoherence as it pertains to biological matter. Arndt et al., 2014. Their research demonstrated that complex molecules, far larger than previously believed, could maintain quantum superposition states, but only fleetingly. The collapse of these states, they warned, could lead to irreversible changes in molecular configuration, with unknown consequences for living tissue. Helios, it would seem, pushed beyond nature's tolerance, forcing living organisms into superpositions too unstable to resolve without damage. The very act of reassembly may introduce errors, minute but cumulative, that manifest as neurological fracturing or existential dislocation. Curiously, similar behavioral anomalies have appeared in unrelated accounts of individuals undergoing advanced virtual reality immersion or experimental brain-computer interface sessions, reported by researchers at the Massachusetts Institute of Technology, MIT, and Stanford University. Slater et al., 2019. Coe et al., 2021. Subjects often exhibited dissociative episodes, memory fragmentation, and identity confusion, symptoms reminiscent of those early Helios test animals. Could it be that teleportation's core challenge is the preservation of consciousness, not merely the rearrangement of matter? If so, the implications extend beyond physics into neuroscience, psychology, and even metaphysics. In the philosophical domain, analogous concerns have been explored through thought experiments such as Derek Parfit's teletransportation paradox. Parfit, 1984. Parfit argued that if a person is destroyed in one location and reconstructed perfectly elsewhere, the question arises, is the reconstructed individual asterisk the same person or merely a perfect copy? Helios appears to have transitioned this dilemma from philosophical musing into grisly reality. The question challenges the foundation of legal and moral frameworks. If continuity of identity cannot be assured, then rights, responsibilities, and even the concept of life itself become tenuous. Could a teleported individual be considered a new entity? Would they inherit previous contracts, debts, relationships? Would they possess the same soul if such a thing exists? Religious scholars have debated similar questions. Theologian John Haught, in Science and Religion, From Conflict to Conversation, Haught, 2012, discusses how emerging technologies force reinterpretations of doctrines surrounding the soul, resurrection, and the afterlife. He suggests that a technology like teleportation might challenge classical notions of soul indivisibility, potentially redefining spirituality in a post-material age. Moreover, the geopolitical ramifications were, and remain, profound. During the height of the Cold War, a technology enabling instantaneous relocation of troops, weapons, or entire populations would have been a strategic game-changer. The very possibility of such a tool may partially explain the relentless suppression and compartmentalization of Helios. Military applications alone would invite uncontrollable escalation. But more insidiously, if teleportation involves the destruction of the original and creation of a copy, then it becomes an instrument of ultimate control and terror. The knowledge that a person's physical existence could be annihilated and replaced at whim is a potent mechanism for authoritarian regimes to enforce obedience or perform covert operations without trace. This is underscored by declassified CIA documents from the 1980s, available via the Crest Archive, detailing covert interest in displacement and duplication technologies for espionage and assassination. While these files never mention Helios explicitly, the recurring themes of identity erasure and replication suggest a shared lineage of clandestine research. In a 2020 declassified memo from the U.S. Department of Defense, there is a startling reference to the continuity of operator consciousness as a critical vulnerability in teleportation protocols. The memo warns, without absolute verification of consciousness transfer, operation risk exceeds acceptable thresholds. Psychological fragmentation of the operator post-transfer could result in mission failure and asset loss. This acknowledgement tacitly confirms what Helios' internal documents implied. The self may not be transferable, and teleportation may engender fragmentation, loss, or worse. Beyond the human domain, ecological consequences were also considered. A 2018 study by researchers at the Max Planck Institute highlighted the complexity of ecosystem interdependencies at the molecular level. Schroeder et al., 2018. Attempts to teleport entire biome samples, as rumored in Project Helios' later phases, risked unpredictable cascading effects when even a single microorganism's genetic structure was corrupted by quantum decoherence. Such failures might unleash uncontrolled mutations or disrupt symbiotic balances, leading to ecological collapse. This might explain why no known attempts at large-scale teleportation of living ecosystems were ever released publicly. Despite these monumental risks, the allure of teleportation never entirely faded. Ongoing experiments in quantum information science, such as those led by the University of Science and Technology of China, USTC, have achieved record-breaking entanglement distances and teleportation rates for photons, Yin et al., 2017, offering hope that some form of safe, non-destructive teleportation might be realized. However, these remain confined to quantum bits, far from the macroscopic complexity of living beings. Thus, Project Helios remains a dark chapter etched in secrets. The terrifying possibility remains that what we call teleportation is not a bridge between places but a corridor through oblivion, a process of death and imperfect rebirth cloaked in the guise of advancement. Before I conclude, it is worth considering a recent theoretical exploration from physicist Sabine Hassenfelder, who in her book Lost in Math*, 2018, critiques the seductive simplicity of technological optimism. She warns that the faith placed in future, miracle technologies often blinds society to fundamental paradoxes and moral dilemmas demanding humility and restraint. Teleportation, as revealed by Helios, is a test case for this warning. It challenges humanity to face the cost of progress, not just in energy and resources, but in identity, ethics, and the very essence of being. As you read these words, remember the final, haunting phrase left in the margins of Dr. Merrow's last known manuscript. Between the here and there lies not space, but a fracture, a wound in the continuum where the self is torn and scattered like stardust, lost forever to the dark. We have not yet been able to heal that fracture. Perhaps we never will. If you choose to delve deeper, beware. Some truths are not merely inconvenient, they are profoundly destabilizing. The next step belongs to you. The science behind quantum teleportation and entanglement, the philosophical puzzles of identity and continuity in teleportation. connections between teleportation and spiritual or religious traditions, real-world breakthroughs, and the challenges of scaling teleportation technology. The hidden stories of secret teleportation projects and their haunting outcomes, ethical, societal, and existential implications of teleportation technology prepare to be inspired, intrigued, and unsettled as we unravel the cosmic dance where physics meets mystery. Hit like if this video sparked your curiosity speech balloon. Share your thoughts and questions in the comments below. Link. Share this journey of discovery with friends who love exploring the unknown.